Have you ever looked up at the night sky and wondered if what we're seeing is just the tip of the cosmic iceberg? We've mapped galaxies, watched stars explode, and even landed on the moon. But here's something wild. We still barely understand what's really going on out there. What if I told you that some stars might not have a surface at all? No photosphere. Just a glowing, bizarre shell or even nothing at all where the surface should be. Sounds impossible, right? But some scientists think these kinds of stars might actually exist. And they could flip our whole understanding of physics upside down. But before we continue, subscribe to the channel so you don't miss out on any of these videos. We're talking about real space mysteries. Not the kind you hear in sci-fi movies, but ones that scientists scratch their heads about right now. Some of these questions are so strange that even the most advanced theories can't explain them. Like stars that don't seem to shine like they should. Objects so dark they're not black holes, yet they swallow light in weird ways. Or signals from deep space that seem to come from nowhere. But let's start with one of the weirdest and most mind-bending things of all, photosphere-less stars. Now, here's the thing. Every star we know of, including our sun, has a photosphere. That's the layer we actually see when we look at the sun through proper filters. It's basically the visible surface of the star. But technically, it's not a surface like a planet has. It's just the outer layer of gas that gets hot enough to shine brightly. Below that layer, light gets trapped and bounced around, so it takes thousands of years for it to even escape. The photosphere is where the light finally makes it out into space. That's why we see stars sparkle in the night sky. They're shining from their photospheres. But what if some stars don't have one? Here's where things get seriously strange. There are theoretical objects that behave like stars in some ways, but without a visible photosphere. These might be very young stars still forming, or exotic objects like quark stars, gravar stars, or even something that hasn't been given a proper name yet. Some researchers have even proposed objects that are in a kind of weird in-between state, not quite a star, not quite a black hole. They might emit radiation in ways we don't fully understand. They might be made of strange matter that doesn't behave like normal gas and plasma. And in some cases, they might be hiding behind a cloud of materials so dense and complex that it blocks or warps the light in completely unexpected ways. Imagine looking at a region of space where you expect to see a bright star, and instead, there's just a weird glow. Or even nothing at all. But when you study the area, there's energy coming out. Radiation. X-rays. Radio waves. Infrared heat. All the signs that something is burning hot and active. Yet, no glowing photosphere. No point of light. No star like we're used to seeing. That's the mystery. Some people think these might be failed stars, called brown dwarfs, that never got big enough to kick off fusion. Others think they could be objects that used to be stars but collapsed into something new, like a quark star. Quark stars, by the way, are mind-blowing on their own. They're made not of atoms, or even neutrons, but of free-floating quarks. That's the stuff inside protons and neutrons. A quark star would be so dense that a teaspoon of it would weigh more than a mountain. And it might not have a photosphere in the way we normally think of one. Just an insanely hot surface radiating weird, high-energy light. Then there are objects like gravar stars. These are purely theoretical, but they're fascinating. A gravar star is like a black hole's cousin. It's an object where space itself collapses inward, but instead of forming a singularity, it stabilizes with some strange quantum material inside. It's not a star in the traditional sense, and it might not shine the way stars do. It could be completely invisible to the naked eye, or it might glow in bizarre ways. Again, no clear photosphere. Now, here's where it gets even more confusing. Some of these objects might look totally normal, until you try to measure their spectra. That's the breakdown of light by wavelength. It's how astronomers figure out what stars are made of, how hot they are, how fast they're spinning, and so on. A normal star has a very specific spectrum. But some mysterious objects give off light that doesn't match any known star. Or worse, no light at all in the visible range. Just heat. Or pulses. Or X-rays. Some astronomers think that if we've already observed photosphere-less stars, we might not have even realized it because we didn't know what to look for. And if these objects do exist, they change everything. It means our models of stellar evolution might be incomplete. That there are kinds of stars, or star-like objects, that we've never properly identified. It also means we might be totally underestimating how many weird things are out there. We've built our entire understanding of the universe on what we can observe. If there are whole categories of objects that don't show up the way we expect, if they don't shine with a photosphere, then how many have we missed? The idea of photosphere-less stars opens the door to a lot of other space mysteries too. Like the so-called dark stars. Not dark matter stars, but actual theoretical stars that could be powered by dark matter instead of fusion. These would shine differently. Or not at all. They might be huge. They might be ancient, formed just after the Big Bang. And we wouldn't even know they were there unless we caught a very specific kind of signal from them. There's also the issue of impossible shadows. Some astronomers have observed areas of space where something is blocking starlight, but there's no visible object doing the blocking. It's not dust. It's not gas. It's just dark. Is it a planet? A failed star? Or something we haven't even imagined yet? That leads into the topic of star ghosts. Light echoes or leftover emissions from stars that should still be visible, but aren't. Some have vanished. Literally disappeared. One moment, astronomers spot a bright star. The next, it's gone. No explosion. No dimming. Just gone. Where did it go? Did it collapse into something that doesn't shine? Did it turn into a photosphere-less object? And what about variable stars that change brightness in unpredictable ways? Some of them flicker so randomly that it doesn't match any known pattern. Not binary eclipses. Not pulsation. Just weird, chaotic shifts. It's possible some of these are hiding something else. Objects that are warping their light or changing how they shine in a way we don't yet understand. Even black holes tie into this mystery. Some theories suggest that under extreme conditions, a collapsing star might stop just short of forming a black hole. Instead, it could become a sort of ultra-dense object with no photosphere, surrounded by a high-energy shell of particles. That would look like, well, nobody really knows. It might show up as a weird radio source. Or as a fast-spinning object releasing jets of energy. Or maybe not show up at all, except as a gravitational anomaly. All of this connects to a bigger question. How much of the universe is invisible simply because it doesn't shine like we expect? We're used to thinking of space in terms of what we can see. Stars shine. Planets reflect. Galaxies glow. But if some objects don't have photospheres, if they emit only in the infrared, or in X-rays, or not at all, then they could be hiding in plain sight. And that changes everything. What if a large percentage of what we think is empty space actually holds photosphere-less stars, just quietly existing, doing things we don't even understand? What if some of them are older than our galaxy? Or closer than we think? And what would it mean for life in the universe? Could these exotic objects be dangerous? Could they host planets? Could they be the source of some of the weird signals we've picked up over the years? Signals we've written off as noise, or interference, or just unexplained? We're only at the beginning of this journey into the unknown. And the more we learn, the more we realize how little we actually know. But one thing's for sure, space isn't empty. It's full of secrets. And some of them are hiding in the dark. These objects challenge everything we thought we knew about how stars work. Think about it. If a star doesn't have a photosphere, what are we even seeing? Or are we not seeing anything at all? Let's break this down in the simplest way possible. A star forms when a huge cloud of gas collapses under its own gravity. The pressure and temperature at the center get so intense that atoms start to fuse. That fusion creates a ton of energy, which pushes outward against gravity. That balance keeps the star stable for billions of years. The heat from the core eventually makes its way to the outer layers and shines out from the photosphere. But some theorists have started to think there might be stars, if you can even call them that, where this last step doesn't happen in the normal way. Maybe they're too massive. Maybe their gravity is so intense that the light doesn't escape in the usual form. Maybe the surface is hidden by something else, like exotic matter. Or maybe, and this one's wild, the star has collapsed into something like a black hole but didn't quite make it all the way. Kind of like being stuck in a cosmic in-between. These could be what some have started calling Photosphere-less stars. The term isn't official, and it's not something you'll find in every astrophysics textbook, but the concept is starting to pop up in fringe discussions, especially in relation to mysterious dark objects we've observed in space. These objects don't behave like black holes, but they don't shine like stars either. You might be wondering, if they don't have a photosphere, how do we even know they're there? Good question. The answer is, we don't really. Not in the traditional sense. What we have are strange readings, sudden dips in light, weird gravitational effects, areas where something should be shining, but isn't. These are places in the universe where something big, something massive, is sitting, but it isn't doing what we expect stars to do. And that has scientists scratching their heads. Let's take a step back. There are already known types of stars that don't shine in visible light very much. Neutron stars, for example, are incredibly dense. They're the leftover cores of massive stars that exploded in a supernova. They're so dense that a teaspoon of their material would weigh billions of tons. And yet, they don't always emit much visible light. Some of them pulse with radio waves, which is how we detect them, as pulsars. But even those have a kind of crust. They still have a structure. A surface. Maybe not like the sun, but still, something solid or semi-solid you can point to. Photosphere-less stars, in theory, are even weirder. Some theories suggest they might be made of exotic matter, stuff that we've never seen before and can barely imagine. Like quark matter or even stranger particles. In those cases, the light might not escape in any recognizable way. The energy could be trapped, absorbed, or just radiated differently, maybe in forms we can't yet detect. And if you think that's bizarre, listen to this. Some physicists have even proposed the idea of dark stars. These would be massive objects that formed early in the universe, powered not by fusion, but by dark matter. Yeah, dark matter, the invisible stuff that makes up most of the universe's mass, but we can't see it, touch it, or interact with it directly. We only know it's there because of how it pulls on other things with gravity. Imagine that. A star that doesn't shine, powered by something we can't even detect directly, sitting silently in space. No light, no warmth, no photosphere. Just darkness. Now, here's where it gets real interesting. Astronomers have started picking up strange signals. They've found stars, or what look like stars, where the light curve doesn't match anything we know. Normally, if you chart a star's brightness over time, you get a predictable pattern. It might flicker, pulse, or even dim if a planet passes in front of it. But some of these objects behave totally differently. The dips in light are uneven. The spectrum is off. It's like the light's being filtered through something we don't understand. Or worse, it's like the light's not there at all. One famous example that got a lot of attention was Tabby's star, also known as KIC 8462852. This star started showing bizarre, unexplained dips in brightness. People threw out all kinds of theories: dust clouds, swarms of comets, even alien megastructures. Yeah, seriously. But some scientists suggested that maybe, just maybe, we were seeing an object that isn't a normal star. What if we were watching something that doesn't have a photosphere? What if it was radiating differently? Now, no one's proven that Tabby's star is a photosphere-less star. Most likely, it's something else. But it opened up a doorway to thinking differently about these objects. What if we've been making a big assumption all along, that all stars must shine the same way? What if we've been missing a whole category of objects because we're only looking for things that glow? Let's go even deeper. In some parts of the universe, especially near the center of galaxies, gravity gets intense. Really intense. We're talking about regions where space itself is being stretched. There are black holes, of course, but also other bizarre things like neutron stars packed into tight clusters. What if in those areas, conditions allow for the formation of stars that don't follow the usual rules? What if gravity bends the light in such a way that the photosphere becomes invisible? Or maybe the light can't even form properly in the first place because of how exotic the matter is? There's another idea, too, one that comes from the edge of theoretical physics. Some scientists have proposed objects called gravastars or boson stars. These are hypothetical things that would look a lot like black holes from the outside, but without the singularity or event horizon. Basically, they'd be super compact, but still have structure. And maybe, just maybe, they wouldn't have a photosphere like a normal star. Or their photosphere would be so warped by gravity that we couldn't detect it. Think about that for a second. If those exist, then we've probably seen them, and just didn't realize what we were looking at. They might be hiding in plain sight, blending in with black holes or dead stars, but actually be something completely new. Something that's never been studied directly. Something that could rewrite entire textbooks. You might be asking, why haven't we confirmed this yet? Simple, because it's insanely hard to detect something that doesn't shine. It's like trying to find a shadow in the dark. We rely on light to tell us almost everything in astronomy. Telescopes detect light, whether it's visible, ultraviolet, X-ray, or radio. When something doesn't emit much, or any, light, it becomes almost invisible. All we have to go on are indirect clues. Gravity, motion, interactions with nearby objects. That's why the search for photosphere-less stars is one of the most exciting and frustrating frontiers in space science. We have hints. We have strange data. But we don't have a smoking gun. Not yet. And if we ever do find one for sure, it could change everything. But even neutron stars still have something like a surface, sort of. It's not like the surface of Earth, but there's a solid crust, made of tightly packed neutrons. And they emit radiation, sometimes in the form of X-rays, gamma rays, or even pulsating radio waves. So we can still detect them, even though they don't glow in the soft, golden light like our sun. But now imagine something even stranger. An object with no true surface. No solid crust. No photosphere to emit light. Just a gravitational presence. Some researchers suggest these might be exotic stars, made of things like quark matter or dark matter. These aren't proven to exist, but they're possible in theory. If real, they could have properties so different from regular stars that they wouldn't even glow in any normal spectrum. Think about how weird that is. A star-like object that doesn't give off light. You wouldn't see it. You wouldn't feel its warmth. The only way you'd know it was there is by watching how it bends the light from other stars behind it, or how its gravity pulls on things nearby. That's not science fiction. That's gravitational lensing, and we've already used it to find things like rogue planets and black holes. So why not something stranger? Let's talk about a real mystery that might hint at this kind of object. Astronomers have found stars that flicker or dim in ways that don't make sense. They're not being blocked by a planet. They're not going through normal cycles. Some of them dim so fast and so irregularly that no known explanation fits. You may have heard of Tabby's star, one of the most famous of these cases. For years, scientists thought maybe there was a cloud of dust, or maybe a swarm of comets. But no theory explains everything we've seen. What if some of these weird flickers are caused by objects that don't have a photosphere? Instead of shining on their own, they could be sitting between us and another star, warping the light, or briefly absorbing it before releasing it in strange wavelengths. That could explain why some dimmings look totally different from typical eclipses. It could also mean that we're looking at some completely new class of star, one that doesn't shine. One that doesn't radiate in the normal ways. A ghost star. Here's another twist. What if these objects are hiding in plain sight? What if some of the so-called dark gaps in the galaxy, those patches where we don't see anything, are full of these weird objects? Imagine whole clusters of them drifting silently through the cosmos, completely invisible unless you know exactly what to look for. That changes everything. It means the map of the universe we've been building might be missing entire cities of stars. Not because they're too far away, but because they don't glow. Now, here's where things really stretch the imagination. Some theoretical physicists have proposed that objects like gravastars or boson stars could exist. These are hypothetical, of course, but they're based on real equations from general relativity and quantum physics. A gravastar, for instance, is a kind of object that might form instead of a black hole. Instead of collapsing into a singularity, the star might create a weird state of vacuum energy inside, surrounded by a superdense shell. From the outside, it could look almost exactly like a black hole, except it might not have an event horizon, and it might not pull in light the same way. If gravastars exist, they wouldn't have a photosphere. They wouldn't have a surface in any traditional sense. And yet they'd be massive, hot, and incredibly strange. Some might even radiate in bizarre bursts, as energy leaks from their shells or surrounding magnetic fields. These objects could be all over the universe, misidentified as black holes, or not identified at all. And then there's the idea of boson stars. These are made of particles called bosons, unlike regular matter, which is made of fermions. Bosons behave differently. They can occupy the same space at the same time, which means a bunch of them can pile into one small area without pushing each other away. Under the right conditions, they could form a kind of star that doesn't shine in normal light. Again, no photosphere. Just a dense, gravitationally powerful lump of pure weirdness. So where does this leave us? It means that star might not mean what we thought it meant. We used to think stars had to shine. That if something glows in the sky, it's a star, and if it doesn't, it's either too far away or too cold. But that's old thinking. These new theories open up a whole other level of possibilities. And they raise huge questions. How many of these objects are out there? Could they be mistaken for dark matter? Could they be influencing the motion of galaxies without us knowing? Could they even be related to some of the unexplained signals we've picked up from deep space? Here's something else to think about. The James Webb Space Telescope is already changing our view of the universe. It can see light from galaxies so far away, we're literally looking back in time. But even JWST has its limits. If a star doesn't have a photosphere, if it doesn't emit normal light, then no telescope, no matter how advanced, would see it the way we see regular stars. We might need totally new kinds of instruments. Gravitational detectors, neutrino observatories, even quantum sensors. It's like realizing there's a second universe hidden inside the one we thought we knew. A shadow cosmos filled with invisible stars. And once you start thinking about that, it's hard to stop. It changes how you look at the sky. It makes you wonder what's really out there in those black patches between the stars. And then the thought hits you, maybe we're surrounded. Maybe the universe isn't just a glittering field of light, but a deep ocean of invisible giants. Silent, massive, and ancient beyond anything we've imagined. They don't shine. They don't burn. They just exist, waiting to be discovered. And that's just the beginning. And if that's true, then the sky is full of ghosts. Not ghosts in the spooky sense, but cosmic ghosts. Massive, silent, invisible giants drifting through space. No glow. No heat that we can easily detect. Just the invisible tug of gravity, warping space around them. That's where this gets both exciting and terrifying. Because if we can't see them, how many are out there? Could there be millions? Billions? Are we living in a galaxy packed with invisible stars that don't shine? Now, let's not get ahead of ourselves. The idea of photosphere-less stars is still very much in the speculative zone. But it's a zone worth exploring, especially when you start digging into the strange behavior of the universe. Some scientists believe we might already be seeing signs of these mysterious objects, and just don't recognize them yet. Think about this. In 2020, astronomers using gravitational lensing techniques noticed certain anomalies, regions of space where something massive appeared to be bending light, but there was no corresponding visible object. They called them dark lenses. These regions weren't black holes, because they didn't exhibit the usual violent X-ray emissions. But they weren't normal stars either, because nothing shined. They were just there. Invisible but undeniable. Silent, massive players in the cosmic game. Could those be photosphere-less stars? It's not confirmed, but it fits. And then there's another possibility: dark matter stars. Dark matter is the invisible stuff that makes up most of the matter in the universe. We can't see it, we can't touch it, but we know it's there because of how it affects the motion of galaxies. Some theoretical models suggest that in the early universe, pockets of dark matter might have collapsed under their own gravity, just like regular matter does to form stars. But instead of shining, these dark stars would be, well, dark. If they exist, they could be all around us, and we'd never know. This leads to a big, mind-blowing question: what if some of the empty space between stars isn't empty at all? What if it's packed with objects that just don't shine? And here's the kicker: what if these objects aren't just passive lumps of matter, but active engines of strange physics? Some scientists have even suggested they might be made of exotic particles like axions or preons, things that go beyond the standard model of physics. These hypothetical particles could interact with gravity and other forces in weird ways, creating objects that have mass, have gravity, but don't emit light. They could be stable. They could be huge. And they could be everywhere. Now, let's go a little deeper into the physics. The photosphere, as we said earlier, is the layer of a star where light can escape. Below that, photons just bounce around, trapped in a kind of radiation soup. If a star is dense enough, the photons never make it out. That's what happens in black holes. They're so dense that even light can't escape. But what if a star was just below that limit? Not quite a black hole, but not a normal star either? This is where a type of object called a gravistar comes in. Gravistar stands for gravitational vacuum star. It's a theoretical object that forms instead of a black hole. Inside, it's a strange form of energy called dark energy, surrounded by a thin shell of ultra-dense matter. But here's the twist: no event horizon. And no photosphere either. So what does it look like? That's the thing, we don't know. If gravistars exist, they could explain a lot of the anomalies we're seeing. Especially the ones that look like black holes but don't act like them. Some gravistar models predict that light might bounce off the outer shell, giving off strange, faint reflections. Others say they might absorb light and re-emit it later in unpredictable ways. That could make them look like stars that flicker oddly or go dark completely, only to brighten again in ways we don't understand. If that's the case, we might have already seen gravistars, and just not recognized them for what they are. And now we get to one of the most chilling thoughts of all. If these objects exist, if photosphere-less stars, gravistars, dark matter stars, or something like them are out there, then they might not be rare. They might be the default. What if most of the matter in the universe isn't made of shining stars and blazing galaxies, but of quiet, cold, invisible giants? It's not impossible. In fact, when you look at the cosmic balance sheet, visible matter is just a tiny fraction of the total. The rest is dark matter and dark energy, stuff we barely understand. And that changes the way we look at the universe. We've always imagined space as mostly empty, with little points of light scattered here and there. But maybe that's wrong. Maybe we're floating in a sea of massive, invisible objects, gently tugging on each other in silence. Maybe the stars we see are just the few that happen to shine, and the rest are sleeping, invisible, or operating in ways we haven't even begun to imagine. Now here's another twist. Some theories suggest that certain quantum effects could create fuzzballs instead of black holes. Fuzzballs are predicted by string theory. Instead of a solid core or a photosphere, the entire structure is a tangled mess of vibrating strings. No event horizon. No singularity. And definitely no photosphere. What would that look like from the outside? Honestly, we don't know. It could appear as a dim, fuzzy sphere. It might not shine at all. Or it could give off strange bursts of radiation at unpredictable times. Again, we might have already seen this and just labeled it as something else. And don't forget about primordial black holes, tiny black holes that could have formed right after the Big Bang. Some versions of this idea suggest that not all of them would collapse completely. Some might remain in a semi-stable state, not quite black holes, not quite stars. No photosphere. No glow. Just gravity. These objects could be everywhere, inside galaxies, between them, even drifting past our own solar system. So what does all this mean for us? It means that space is a lot weirder than we thought. And way more mysterious. The idea of stars without photospheres isn't just a fun thought experiment. It's a clue, a tiny crack in the wall of what we think we know. And through that crack, we might glimpse a whole new universe. One where light isn't the rule. One where mass and gravity and quantum mechanics play by different rules. One where visibility is the exception, not the norm. And maybe that's the real mystery. Not what we see, but what we don't. Or prions, particles even smaller than quarks. If such exotic matter can clump together under gravity, it might not behave like anything we've ever seen. It wouldn't glow. It wouldn't radiate heat in the same way. It might not even interact with regular matter beyond gravitational pull. That could explain the dark lensing events. That could explain the flickering stars. That could explain the invisible mass that keeps showing up in calculations but never appears through any telescope. Let's dig even deeper into this. Some advanced theories in theoretical physics, like certain versions of string theory and loop quantum gravity, suggest that under extreme conditions, matter might not even form into atoms as we know them. Instead, it could collapse into exotic states, bound together by forces that have nothing to do with electromagnetism, which is the force responsible for almost all the light we see. If that's the case, a star, made of this stuff could have no electromagnetic signature at all. No light. No radiation. Just gravity. Imagine billions of these ghost stars drifting silently across galaxies, entirely invisible to traditional observation. That sounds like science fiction, but it's grounded in very real, cutting-edge physics. Now picture this, an area of space that appears completely dark, completely empty. But as a spacecraft drifts through it, its trajectory changes. It curves slightly, like something is tugging on it. Instruments go wild. Not from collision, not from heat, but from pure gravitational distortion. No lights. No flares. No bursts. Just a quiet, invisible force pushing and pulling. That's what encountering a photosphere-less star could feel like. And we may have already gotten close. Some space probes, like Voyager and New Horizons, have reported odd fluctuations in background radiation and gravitational noise. Tiny, almost unnoticeable shifts. NASA never confirmed anything unusual, but a few independent researchers believe these anomalies could be caused by invisible, massive objects nearby. Objects that don't shine. Objects with no photosphere. Now, let's talk about another possibility that's even more bizarre: failed black holes. What if some massive stars collapsed almost completely, but didn't quite reach the point of becoming a black hole? In theory, if something stopped the collapse at the last second, maybe some unknown repulsive force or exotic form of matter, it could freeze in a halfway state. Not a neutron star. Not a black hole. Something new. Something dense, dark, and incredibly weird. These, almost black holes, might have no surface, no radiation, no photosphere. And because they don't collapse fully, they also wouldn't have an event horizon, the point of no return. That changes everything. Without an event horizon, these objects wouldn't trap light the way black holes do, but they wouldn't emit light either. They'd just sit there, dark, dense, detectable only by their effect on the space around them. This is exactly the kind of object that could be mistaken for empty space or a glitch in a telescope. But it wouldn't be a glitch. It would be a new type of cosmic object, maybe one that bridges the gap between matter and pure geometry. Let's pause for a second and think about how radical this is. For hundreds of years, astronomy has relied on one simple rule: if it shines, it's there. If it doesn't shine, it's invisible. But now we're finding cracks in that idea. More and more, astronomers are being forced to look at the sky in new ways, not with eyes, but with math, gravity, and radiation that we can't see with our eyes. This is where the idea of Photosphere-less stars turns from fringe theory into real scientific curiosity. It's no longer just about mysterious objects. It's about rethinking what a star even is. For most of human history, we've thought of stars as big burning balls of gas. But what if that's just one type of star? What if stars can take many forms, some bright and obvious, others dark and hidden? That opens up a floodgate of questions. Could these dark stars affect planetary orbits? Could they be hiding in our own solar system, cloaked in invisibility? Could the gravitational anomalies we see in the outer solar system, like the unexplained orbits of some distant objects, be caused by a rogue photosphere-less star drifting nearby? Some scientists already think something massive is lurking beyond Neptune, something they call Planet 9. But maybe it's not a planet at all. Maybe it's not even visible. Maybe it's one of these silent giants, a failed star or exotic object with no photosphere, bending our solar system in ways we don't yet understand. And if even one of those objects is nearby, how many more are far away? Let's take it even further. What if the earliest stars in the universe weren't like our sun at all? What if the first stars formed mostly from dark matter instead of hydrogen and helium? These would be the original Photosphere-less stars, massive, invisible, long dead, or maybe still drifting quietly through the cosmic void. If that's true, it means our entire view of cosmic history could be skewed. The universe may have had an invisible phase we've never been able to detect, a time when stars existed but didn't shine. That would mean we're missing an entire chapter of the universe's story. So now we have to ask the ultimate question: what are the limits of what we can observe? Because maybe we're not seeing the whole universe at all. Maybe we're only seeing a small, glowing fraction of it. The rest, the darker, stranger part, could be hiding in plain sight, just outside the range of our senses. We keep launching better telescopes, more powerful satellites, infrared scanners, gravitational wave detectors. And with each new instrument, we peel back another layer of the cosmic onion. But no matter how deep we go, we keep finding more shadows, more weirdness, more unanswered questions. And right at the heart of that mystery are the objects that don't shine. Photosphere-less stars are not just a scientific oddity. They're a symbol, a clue, a reminder that we still know almost nothing about the true nature of the universe. We've built our understanding around what we can see, but the universe may be built mostly from what we can't. And maybe, just maybe, the biggest, most important things in the universe are the ones that don't light up at all. But something in between. Something with the mass and density of a collapsed object, but without an event horizon. No light escapes, not because of total gravitational doom like in a black hole, but because there's simply no mechanism for light to be emitted in the first place. These, almost black holes, could be entirely invisible, yet not as extreme as real black holes. And because they don't have event horizons, they wouldn't emit Hawking radiation or cause the same kinds of cosmic fireworks we associate with collapsing stars. They just sit there in the dark, warping space-time, untraceable by light, only detectable through gravity. Imagine that scattered throughout our galaxy are millions of these things. Some alone in deep space, others orbiting normal stars. Maybe even within binary systems, orbiting a shining star while they themselves emit nothing. It would be like having a cosmic twin that's completely invisible to the eye but constantly pulling on you. We've already found binary star systems where one member is completely invisible, yet exerts immense gravitational pull. In many cases, scientists assume it's a black hole or neutron star. But what if some of those systems hide a different kind of object, one we've never seen directly, because it doesn't shine? Now, let's push this mystery even further. What happens to light when it passes through a gravitational field? It bends. That's gravitational lensing, and we've been observing it for decades. But sometimes, astronomers notice lensing effects where nothing is visible, no star, no galaxy, no black hole. Just bent light. It's like watching a ripple move across water without seeing what caused it. In the most extreme examples, the lensing is so precise, so focused, it suggests a very compact, dense object. And when there's absolutely no visible light coming from that object, the mystery deepens. Scientists have started calling some of these phenomena dark stars. Not because they're evil or scary, but because they are massive, compact, and totally invisible. Some dark stars might be ancient, made of matter from the early universe. Others might be failed stars that never ignited. But some could be entirely new, objects that never had a photosphere to begin with. And that raises another question: how would such a star form? In our understanding of star formation, clouds of gas collapse under gravity, heating up as they compress. Eventually, they get hot enough to ignite nuclear fusion. That fusion produces light, radiation, which forms the photosphere. But what if something stops that process? Maybe the cloud collapses too fast. Or maybe it's made of material that doesn't interact with light. It could skip the glowing phase entirely. No light. No photosphere. Just mass, density, and gravity. Now consider dark matter again. Dark matter makes up more than 80% of all matter in the universe, yet we've never directly seen it. We know it's there because galaxies spin faster than they should. There's extra gravity holding things together. Dark matter doesn't interact with light. It doesn't emit, reflect, or absorb photons in any known way. That makes it a perfect candidate for building photosphere-less objects. If clumps of dark matter gathered together in the early universe, they might form stable, invisible structures, essentially dark stars. Some physicists believe that these dark stars could be gigantic. In the early universe, when conditions were more extreme, dark matter might have clumped into stars thousands of times more massive than our Sun. These hypothetical monsters wouldn't shine. But they might still be forming planets. They might still have gravitational fields strong enough to pull in dust and debris. They could have entire systems orbiting them, completely hidden from view. And here's where it gets even wilder. If planets can orbit dark stars, then technically, you could have a planet floating in what seems like the empty void, no sun in the sky, yet locked in stable orbit around a totally invisible mass. The night sky would be forever black. There'd be no sunrise, no shadows. Just eternal darkness. And yet, gravity would hold everything in place, like an invisible puppet master. What would life be like on such a planet? Most likely, it would be freezing. But then again, maybe not. If the planet had enough geothermal energy, or if tidal forces from its orbit around the massive object heated it internally, life might still survive. Maybe not life like us, but some form of biological activity. Maybe microbial. Maybe more. And this raises a question most people never think to ask. Are there civilizations out there orbiting stars we can't see? We search the sky with telescopes, looking for signs of life around bright, shining stars. But if intelligent life evolved in a system around a photosphere-less object, we'd never know. Their home would be invisible to us. No light, no signals. Even if they broadcast radio waves, those signals might be too weak or distorted to reach us. We could be completely blind to entire civilizations simply because their stars don't glow. This shifts our entire perspective. We assume that stars are beacons, that they light up the universe and show us where to look. But what if the majority of mass in the cosmos is hidden? What if the stars we see are just the tip of the iceberg, and below that glowing tip is an ocean of invisible objects, hiding planets, moons, maybe even alien cities? Let's go even deeper. Some theories suggest that the first stars in the universe, population 3 stars, were massive, short-lived, and different from anything we see today. But we've never actually observed one. What if that's because they didn't shine in visible light? Maybe some of them collapsed into objects that never emitted traditional radiation. Maybe the very first generation of stars ended not in bright supernovas, but in quiet, invisible deaths, becoming the very first photosphere-less objects in the cosmos. And if that's true, then these ghosts of the early universe are still drifting out there, ancient beyond imagination, carrying the fingerprints of a time before galaxies even formed. And we haven't even touched the possibility of artificial objects. What if some of these invisible masses aren't natural at all? Some advanced civilizations, if they exist, might find ways to hide themselves completely. Not just by turning off the lights, but by engineering stars that emit no radiation. Think about it. If you wanted to stay hidden from other life forms in the universe, the best way to do that would be to eliminate your electromagnetic signature. No light. No heat. Just gravity. You'd appear completely invisible to every telescope ever built. And how would we find you? We'd only notice the tiny wobbles in nearby stars. Or strange gravitational lensing that doesn't match any known source. Or maybe, just maybe, tiny shifts in space probes, unexplained anomalies in their paths as they cross interstellar space. This all points to one truth: the universe might be hiding more than we ever imagined. Not because it's dark, but because it's invisible in ways we haven't even begun to understand. If the temperature and pressure get high enough, nuclear fusion kicks in. That's what gives a star its glow, the nuclear fusion reactions in its core releasing energy that radiates outward, creating the photosphere, the visible surface of a star. But what if that process never starts? What if something interferes with the ignition of fusion? One possibility is that the collapsing gas cloud contains elements or particles that disrupt the fusion threshold. Maybe dark matter mixed in, or maybe the cloud formed in a region of space with an unusually strong magnetic field or high gravitational turbulence. It's possible that the cloud collapsed into a dense object without ever getting hot enough to ignite. In that case, you'd be left with a dense, massive object that looks like a star, acts like a star gravitationally, but gives off no light. No photosphere. Just cold, silent mass. And now imagine something even wilder. What if these objects formed not in our universe, but in a parallel universe, or at the very beginning of time, when the laws of physics might have been slightly different? Some cosmologists believe there may have been tiny fluctuations in the rules of nature during the Big Bang. If even a fraction of a percent of those fluctuations created matter that didn't behave like regular atoms, it could have seeded invisible stars. These objects could be made of mirror matter, a hypothetical form of matter that mirrors the properties of regular matter but doesn't interact with electromagnetic forces. That would make it completely invisible, no light, no heat, no photosphere. And this isn't just wild speculation. Researchers at CERN and other particle physics labs have been exploring ideas like mirror matter and hidden sector particles for years. If these particles exist, they might form their own kind of atoms, their own kind of chemistry, even their own kind of stars. Stars that float right through ours without a trace. That might already be orbiting our galaxy, undetected, silent, and massive. Now think about the implications. If we're missing an entire class of stellar objects, ones that don't glow, don't radiate, and don't make themselves known except through gravity, our understanding of the universe might be wildly incomplete. All of our models about galaxy formation, star distribution, stellar life cycles, they could all be missing a major piece. Our maps of the sky might just be showing the lit up part of the universe, while an invisible framework of ghost stars surrounds us. And here's another unsettling thought: what if some of these stars are close? Like really close. Scientists have already speculated about nearby rogue planets, free-floating worlds not tied to any star. Some estimates say there could be billions of them just in our galaxy. But what if there are rogue stars too? And what if they don't glow? They could drift through the solar system at immense distances, beyond Pluto, beyond the Oort cloud, and we never know unless their gravity disturbed something. There could be one right now, slowly passing between Earth and Alpha Centauri. No light. No sound. Just mass, distorting space-time, undetectable by telescopes. The only way we might notice it is if it perturbs the orbit of a far-off comet, or causes a faint lensing event in the background starlight. And there's a precedent. In 2018, scientists announced the detection of a large, distant object beyond Neptune, something massive enough to influence the orbits of other trans-Neptunian objects. They called it Planet 9. But years later, no one's found it. Could it be that we're looking for a planet, when what's really out there is a photosphere-less star? One that doesn't glow. One that slipped into our solar system ages ago, and has been drifting silently ever since. We may never know for sure. But the next generation of telescopes, like the Vera Rubin Observatory and the Nancy Grace Roman Space Telescope, are designed to detect subtle changes in the sky. They'll scan for gravitational lensing, for unexplained stellar motions, for flickers and shadows that hint at something invisible. And when those instruments come online, we might start seeing what we've missed for centuries, the dark side of the cosmos. Not metaphorically dark. Literally dark. Entire worlds and suns that never learned to shine. Photosphere-less stars might not just be theoretical anymore. They might be the missing link. The key to unlocking hidden mass. The answer to the dark matter riddle. Or even the clue that shows us the universe is stranger than we've ever imagined. Because here's the truth. For every shining star we see in the night sky, there may be dozens, maybe hundreds, of unseen giants lurking in the void. Quiet. Cold. Massive. Waiting. Entire hidden structure lies beneath it, like trying to understand the ocean by only looking at the surface. We could be surrounded by these invisible objects, these photosphere-less stars, without ever knowing it. They could outnumber ordinary stars. They could shape the movements of galaxies. They could even form entire dark star clusters, or invisible galaxies, that drift silently through the cosmos. Now let's talk about invisible galaxies for a second. Astronomers have recently discovered galaxies that appear to be made almost entirely of dark matter. Galaxies with very few visible stars, yet with enough mass to hold themselves together. These structures are puzzling, but what if they contain a hidden population of photosphere-less stars? Objects so faint or non-interacting that our best telescopes can't even catch a glimpse of them. That would mean entire stellar populations are cloaked from our eyes. The James Webb Space Telescope, with its extreme sensitivity to infrared light, was expected to uncover hidden objects that Hubble couldn't see. And it has. But even Webb is limited, because it still relies on light. If something doesn't emit or reflect light in any spectrum, not even infrared or X-ray, then it stays invisible. That's why gravitational effects have become our most powerful clues in the hunt for these unseen stars. And here's another chilling thought. What if one of these objects were right next to us? Not light years away. Not even trillions of miles away. What if a photosphere-less star was drifting silently somewhere in the outer solar system, past the Kuiper belt, or even closer, hiding in the Oort cloud? There have been irregularities in the orbits of long-period comets and outer dwarf planets that some scientists believe could point to a ninth planet, so-called Planet 9. But what if it's not a planet? What if it's a star that never glows? A rogue object with the mass of a star, pulling on our solar system, never seen, never confirmed, just inferred through strange movements. That could explain a lot. It could explain gravitational anomalies we've recorded for decades. It could explain unusual comet trajectories, mysterious tugs on satellites, and unexplained fluctuations in cosmic microwave background readings. And here's the most haunting part. If such an object came closer, we wouldn't know until it was already here. No light. No radiation. No warning. Just a sudden tug. A subtle bending of spacecraft paths. Maybe a slight darkening of background starlight. Then, gravity. That's all we'd get. That's all we'd have to go on. By the time we detected something was there, its gravitational pull would already be changing the fabric of our solar system. Now let's dive even deeper into theoretical territory. Could these invisible stars host planets? Think about that. A solar system orbiting around a completely dark star. The planets wouldn't receive light. They'd be orbiting in total darkness. If they had atmospheres, they might trap heat from internal planetary sources, but without light, photosynthesis would be impossible. The life forms, if any, would have evolved in pitch-black environments. No vision, only touch, echolocation, maybe even magnetic senses. Entire ecosystems could exist in blindness. And if such life developed intelligence, they might never even know what light is. They might not even imagine the concept. To them, the universe would be pure void. They wouldn't know stars exist. They wouldn't see galaxies. Their entire reality would be based on gravity and heat and sound. If they sent probes into space, they might be utterly confused when their instruments detected bright radiation far away, light that makes no sense to their dark evolved brains. Now flip that idea. What if one of those planets escaped orbit and entered our neighborhood? Or worse, what if such a civilization found us first? They might see us as impossible, alien, blinding. Our light might be as bizarre to them as darkness is to us. Communication could be almost impossible. Their sensors wouldn't detect anything beyond gravity and maybe neutrinos. And ours? They wouldn't even know how to look for them. Because how do you detect what doesn't shine? And that's what makes photosphere-less stars one of the most haunting mysteries in all of astrophysics. They defy what we thought stars were supposed to be. They reveal how much we rely on light, how biased our whole understanding of space is toward what glows. We've built entire telescopes, satellites, and space missions around light. But the universe may be whispering that light is just the tip of the iceberg. The real universe, the dark universe, is much bigger. And much more hidden. Just a sudden shift in gravitational behavior. A subtle warping of orbits. A slow, creeping influence we might not even notice until it was too late. If a photosphere-less star drifted into our neighborhood, it wouldn't announce itself with a blazing sky or a burst of radiation. There'd be no light show. Just quiet, invisible motion. Planets would start to wobble ever so slightly. Tides might behave differently. Maybe our satellites would start shifting out of alignment. And by the time we realized what was causing it, it could be right on top of us. Now, some scientists might say this sounds like science fiction. But let's be real. So many things that were once dismissed as fantasy are now textbook science. Black holes, for example, were once considered ridiculous. Einstein himself wasn't sure they were real. Today, we've photographed one. Dark matter? Still not fully understood, yet it makes up most of the universe. So why not invisible stars? Why not photosphere-less stellar bodies that evade our instruments, but leave behind clues in the way they bend space and time? Let's go deeper. The formation of a typical star involves the delicate dance of gravity pulling gas inward and radiation pushing outward. The moment the balance tips, boom, you've got a star. But what if there are places in the universe where this balance never quite gets there? Maybe the gas is too cool, or the surrounding conditions prevent the ignition of fusion. These clouds could collapse into what we might call failed stars. But that term doesn't quite fit if they're still massive and exerting gravitational force. Maybe they're not failed. Maybe they're just different. And there's something called a black dwarf. It's what a white dwarf becomes after it cools completely. Now, theoretically, black dwarfs don't exist yet because the universe isn't old enough. White dwarfs haven't had enough time to cool that far. But someday, the universe will be filled with them. Cold, dark, dead stars that once shined and now drift silently through space. These will be true photosphere-less stars in the most literal sense. But what if, some mechanism sped up that cooling process? What if, somewhere out there, black dwarfs already exist? Or better yet, what if something forms that skips the light phase altogether? No white dwarf. No glow. Just darkness. There's also speculation that massive primordial stars may have formed in the early universe and died quickly, leaving behind dense remnants that never had visible photospheres to begin with. These objects, formed in extreme early universe conditions, might behave in ways we can't even model yet. They could be the ancestors of black holes or the seeds of galactic clusters. And they might still be out there. Watching. Moving. Influencing. Let's not forget exotic matter stars, strange stars, quark stars, and the hypothetical preon stars. These theoretical entities are believed to exist at ultra-high densities where matter breaks down into its most fundamental particles. If these stars do exist, they might not radiate in the way we expect. They might be so compact and so stable that they emit little to no radiation at all. No photosphere. Just mass. And now let's come back to something deeply unsettling: gravitational lensing. It's one of the few tools we have to detect invisible objects. If something passes in front of a more distant light source and bends that light around itself, we can see the distortion, even if we can't see the object. These distortions, these gravitational fingerprints, have revealed things that don't match any known category. Lensing events that don't have any visible cause. Some of these may be black holes or brown dwarfs. But others might be something else. Photosphere-less stars might be leaving their mark through these brief gravitational anomalies. The light curves don't match known stellar types. The timelines don't add up. These lensing blips are like fingerprints left by ghosts, present but invisible. So what does this all mean for us? It means we're living in a universe filled with mysteries that don't just lie beyond our reach, they lie beyond our sight. And maybe, just maybe, the objects that don't shine are the ones that matter most. Maybe they shape the paths of galaxies. Maybe they hide the origins of dark matter. Maybe they're the missing pieces of the cosmic puzzle we've been trying to complete for over a century. And here's the kicker. Every time we point our telescopes into the night sky, we're seeing less than half the truth. We're missing everything that doesn't shine. We're missing the photosphere-less stars. Just straight to darkness. This is where things start to bend the limits of what we think we know about physics. Because when we assume that all stars must emit light, we're putting a filter on reality. A filter that says, if we can't see it, it doesn't exist. But the universe doesn't play by our rules. It never has. And if photosphere-less stars exist, they challenge that assumption in the most brutal way possible. They could be everywhere. Not because they're rare, but because we simply haven't been able to find them. Think about this. Stars that don't emit light might not just be oddities or failed outcomes. They could be an entire classification of celestial object we've never properly studied, because we've never even known where to look. Not even how to look. And in the vast darkness between galaxies, where there's little gas, little radiation, little activity, there might be countless of these invisible masses just waiting. Or more terrifyingly, moving. And if they move, they could collide. Merge. Tear through star systems without anyone knowing until it's far too late. It's like watching waves on the ocean, but not realizing that a submarine is cruising silently just beneath the surface. It doesn't matter how calm the water looks, something is there. You just can't see it. Now let's go even deeper, into the concept of star evolution. From protostars to red giants to supernovae to white dwarfs and neutron stars, we've mapped out this journey in a way that makes sense, on paper. But these processes are built on observations, and every observation we've ever made has been limited by light. That's a massive problem. Because what if entire phases of stellar evolution exist that produce no light at all? What if some stars evolve differently? Quietly? What if some stars don't explode into supernovae, but instead collapse inward without a sound or spark, never forming a black hole, but instead something new? A photosphere-less object could be the final state of an alternative stellar life cycle we've never imagined. Something that never flares, never glows, never reflects light. Just contracts and cools until it becomes something as dense as a white dwarf but darker than the deepest cosmic void. And here's a wild but very real possibility. What if some of the gravitational waves we detect, those tiny ripples in spacetime that were first measured in 2015, aren't just caused by black hole collisions or neutron star mergers? What if some of them are from the collisions of invisible stars? Think about that for a second. We might be detecting the death of stars that never lived in light. We might be hearing the echoes of cosmic collisions that no one will ever see. Let's also talk about how this affects our understanding of galactic structure. Every galaxy we've ever observed is built on a framework of visible stars, interstellar gas, dust, and dark matter. But dark matter is still a giant mystery. It doesn't emit or absorb light, yet it holds galaxies together with its gravity. What if part of what we call dark matter isn't exotic at all? What if it's made, in part, of failed stars, collapsed stars, or photosphere-less stars? That would rewrite our understanding of what a galaxy even is. And it gets even crazier when you think about galactic collisions. When two galaxies merge, stars usually don't collide directly because they're spaced so far apart. But gravitational interactions tear things apart, creating new star-forming regions and violently rearranging cosmic structures. If invisible stars are in the mix, objects we don't detect, they could change everything about how these mergers happen. They could create gravitational anomalies that make us miscalculate mass distributions. They could trigger unexpected shifts in stellar motion. Entire galactic maps could be based on incomplete data, because they're missing pieces we can't see. Even dark energy, our biggest mystery, might be misunderstood if we're leaving out a population of massive, dark objects from our equations. What if the accelerated expansion of the universe isn't just driven by dark energy, but also by hidden gravitational effects from these unseen stars? The rabbit hole is deep, and we're only starting to see the edges of it. What if some of those gravitational waves aren't coming from black hole mergers or neutron-star collisions, like we've assumed, but from entirely different kinds of events involving objects we can't see? Think about it. Gravitational waves are ripples in spacetime caused by the acceleration of massive objects. But they don't care whether those objects are bright or dark. If something massive moves fast enough, the universe vibrates. So, what if those vibrations are being caused by the collisions or close encounters of photosphere-less stars? Objects so dark, so completely non-emissive, that the only evidence of their existence is a ripple felt across millions or billions of light years. We might have already detected them. We might already have the data. But because we don't have a visible counterpart, no flash of light, no X-ray burst, we dismiss it or categorize it as a black hole event. But what if we're wrong? What if we've been mislabeling entirely new classes of astrophysical phenomena simply because they don't come with the kind of fireworks we expect? This isn't just a question of misclassification. It's a question of a completely hidden layer of the universe. One that doesn't just avoid our eyes, but evades our theories altogether. Now, here's something else that'll twist your brain a little. When we say light, we're usually referring to visible light, but stars emit across a broad spectrum: infrared, ultraviolet, X-rays, gamma rays. A photosphere-less star might not emit in the visible range at all. Maybe it's too cold. Or maybe it's made of some exotic matter that simply doesn't produce electromagnetic radiation in a form we can detect. Maybe it only interacts via gravity, warping space but giving us no photon trail to follow. What if it only radiates in unknown frequencies or exotic particle emissions we haven't even discovered yet? We assume that if something exists, we should be able to detect it eventually. But what if that assumption is wrong? What if entire galaxies, or clusters of them, are composed of material that doesn't play by the rules we've written into our textbooks? Maybe what we call dark matter is just a placeholder for these unseen giants. Not invisible particles, but invisible stars. Cold, dark masses drifting across the void in numbers that dwarf the visible stars we can count. And here's something even wilder. If these objects are made of exotic forms of matter, their internal physics could be completely alien. They might not follow the same rules of thermodynamics we based our stellar models on. Maybe fusion isn't their main energy source. Maybe they derive energy from dark energy fluctuations or quantum anomalies in the vacuum of space. It sounds like pure speculation, and it is, but so was the idea of atoms, once. So was the idea of curved space. So was the idea of time dilation. Science always begins with someone asking, what if everything we think we know is only half the story? And the thing is, these photosphere-less stars might not even be rare. They might be common. That's the scariest part. Because if they're truly invisible to all the instruments we currently use, if they neither emit nor reflect any light, in any wavelength we know of, then we wouldn't just have missed a few. We might have missed most of them. Our maps of the cosmos might be like drawing the outline of a forest by only charting the trees that catch sunlight, completely blind to the ones growing silently in the shadows. This could change everything. If these objects are out there in large numbers, then it means that the universe is far more massive and far more structured than we thought. Not in the way we expected, but in a way that's hidden behind a curtain we didn't know existed. Imagine trying to map a city at night using only the streetlights. You'll see roads, intersections, some buildings. But you'll miss everything that isn't lit, entire neighborhoods, alleyways, parks, even massive skyscrapers that just don't have their lights on. That's the situation we're in with the universe. We're mapping only what glows. But the rest? The dark buildings? The invisible roads? They're there too, we just haven't figured out how to see them. Now picture this. Somewhere out in deep space, there's a rogue object the size of our sun. But it's not shining. It doesn't have a surface temperature that emits visible light. It doesn't reflect. It doesn't scatter light. It doesn't even interact with nearby matter in a noticeable way. It just moves slowly, silently, like a ghost. And it's heading straight toward a star system. Not because it's malicious, it's just obeying gravity. But no one sees it coming. Not until its presence starts warping the orbits of planets. Not until strange gravitational anomalies appear in telescope data. And even then, all we'll know is that something's wrong. We won't see it. We'll only feel its effects, like a phantom brushing past us in a dark room. And maybe that's already happening. Maybe our models of planetary motion, which seem to break down at the edges of our solar system, aren't wrong because of flawed math, but because there's something we can't see out there. A photosphere-less object with the mass of a star, just beyond the reach of our light-based instruments. And it's not just one object. It could be hundreds, thousands, maybe whole groups of these things, bound together in structures we've never imagined. Not visible galaxies, but ghost galaxies. Stellar graveyards made of dark suns, drifting in patterns we'll never see, but might one day feel. Let's go even deeper. The formation of a star depends on mass and heat. Gas clouds collapse under gravity, temperature rises, fusion ignites, and light spills out. That's how a star is born, or at least, that's how we think it works. But what if there's another pathway? What if under certain conditions, different chemical compositions, different environmental factors, these clouds collapse, but fusion never kicks in? Or maybe it starts, but it's weak, uneven, unstable. Just enough to heat the core, not enough to produce a full photosphere. These objects would be massive, dense, maybe even long-lived. But cold. Quiet. Unlit. And because they don't shine, we've never known they were there. And that brings us to something even more frightening. What if these dark objects can evolve? What if they don't just sit there quietly? What if they change, slowly, over millions of years? What if they absorb other matter? What if they merge, becoming more massive, more dense, until they collapse into something even darker? Maybe they become black holes, not through a dramatic supernova, but through a slow, silent death. And maybe we never see it coming because there's no light to mark the transition. Just gravity. Just a slow, invisible warping of space. Or maybe they don't collapse at all. Maybe they become something new. Something we don't have a name for. An object made of exotic matter, cold as interstellar space, heavy as a collapsed core, and utterly undetectable by traditional means. An object that doesn't fit into any known category, either star nor planet, either black hole nor neutron star. A ghost object. A rogue entity. Something completely outside our current understanding of physics. Now think about the implications for time. If these objects exist, and they've always existed, then our entire timeline of the universe is missing key data. Maybe the early universe produced more of these dark stars than luminous ones. Maybe the first stars weren't shining beacons, but silent giants that seeded space with gravity, not light. Maybe our entire picture of cosmic history is skewed, because we've only ever looked at what glows. But the real architects of the cosmos might have worked in the shadows, shaping galaxies with invisible hands. And here's where things get philosophical. We always talk about the visible universe. But what if visibility is an illusion? What if what we can see is just the tip of the iceberg, the thinnest layer of a much deeper, much darker truth? What if we are, and always have been, surrounded by these objects? What if we live in a universe of phantoms, silent, massive, ancient presences that we've never seen, but that shape everything around us? Imagine the psychological impact of truly proving these objects exist. Of suddenly realizing that the night sky we thought we understood is only a small fraction of reality. That behind every patch of blackness, there could be a star-sized object, watching, drifting, waiting. Imagine the paranoia, the awe, the rewriting of textbooks. And imagine the possibilities. If we can detect these objects, not with light, but with gravitational mapping, with neutrino detectors, with technology not yet invented, we could start to build a new map of the universe. One based on mass, not brightness. One that reveals not just what's pretty, but what's real. We might discover whole regions of space we thought were empty are actually crowded with these cold suns. Maybe they've formed massive webs, scaffolding the universe in invisible strands of gravity. And here's the next level. What if advanced civilizations, ones older than ours, more evolved, aren't using bright, hot stars as power sources? What if they've learned to tap into these photosphere-less stars instead? Objects that emit no light, draw no attention, remain hidden from the rest of the cosmos. Perfect for a civilization that doesn't want to be found. Maybe the best hiding place in the universe isn't behind a planet or inside a nebula. It's around a star that doesn't shine. But what if that last part, the ignition of fusion, doesn't always happen? What if the cloud collapses, the object gains mass, it becomes incredibly dense, but for some reason, fusion never turns on? Maybe the temperature doesn't get high enough. Maybe the composition of the gas is slightly different. Maybe it's made of material that resists fusion altogether. So now you've got this massive object, bigger than Jupiter, maybe even as massive as the Sun, but it never lights up. It just sits there. Silent. Cold. Invisible. Still exerting gravity. Still influencing everything around it. But undetectable by our eyes, our telescopes, our satellites. Not because it's hiding, but because it doesn't give off light in any way we can recognize. We already know brown dwarfs exist. These failed stars are bodies that are too big to be planets but too small to sustain hydrogen fusion. They glow faintly in infrared, but even then, they're hard to find. Most were discovered not by looking for them directly, but by spotting what they do to nearby stars, causing slight wobbles or shifts. Now imagine an entire spectrum beyond brown dwarfs. Objects that don't glow at all. Maybe they're older. Maybe they've cooled down completely. Maybe they're not made of the same stuff. Maybe they formed from dark matter itself, compressing under its own mysterious rules into massive, dense, lightless bodies. And now let's really stretch it. What if these photosphere-less stars aren't just the result of failed fusion, but of something entirely different? A different phase of matter. We already know that under extreme conditions, matter can shift into states we don't encounter on Earth. Neutron stars, for example, are basically giant atomic nuclei. So what if there are stars made entirely of exotic matter, quark matter, or something we haven't discovered yet? These objects wouldn't emit light in the traditional sense because they don't operate by traditional physics. Maybe they're the leftover cores of stars that collapsed incompletely. Not quite black holes, not quite neutron stars, just something else. Something dark. Something real. And here's another twist. Stars don't just live alone. They form in clusters, orbiting each other, pulling on each other with gravity, forming complex systems. If photosphere-less stars exist, they might be part of those systems too. Binary star systems where one companion is invisible. Triple systems where 1/3 of the mass is undetectable. That would completely mess up our models. We'd be measuring star movements and coming up with weird numbers, like stars orbiting empty space or showing unexpected accelerations. We'd think, there must be a black hole there. But no, it could be a lightless star. A ghost companion. Not radiating, not detectable with X-rays, but still there. Still pulling. Still influencing the dance of the stars. Now, if you're thinking this sounds a lot like dark matter, you're right. But it's not quite the same. Dark matter is theorized to be non-baryonic, meaning it's not made of the same stuff we are. But what if there's a hidden class of baryonic matter, normal matter, that just isn't shining? Stars made of normal protons and neutrons that never lit up. If enough of them exist, they could explain part of the missing mass of the universe. And because they're not luminous, they could have completely escaped detection during every deep sky survey we've ever done. We've been measuring the light, but they never gave us any. And now let's throw in gravitational lensing. When a massive object passes in front of something bright, like a star or galaxy, it bends the light behind it. This is how we find planets and dark objects. by noticing the background distortion. But what if we've already detected these distortions and chalked them up to other things? What if there are places in the sky where gravitational lensing occurs, but there's no visible object in front of the background star? We might assume we made a mistake. But the truth could be that a photosphere-less star was responsible. We just didn't know what we were looking at. It's a terrifying thought. There could be thousands, maybe millions of these things drifting around, bending light, warping orbits, nudging galaxies, and we never see them. Not unless we start using indirect methods more seriously. Not unless we accept that some things in the universe might never glow. That some stars might live and die in complete darkness. That our assumption. If it exists, it must shine. Might be the biggest blind spot in all of astronomy. Then those systems could be filled with them. Imagine a stellar cluster where none of the stars emit light. A completely dark system of massive, invisible objects orbiting a common center of gravity. Nothing to reflect. Nothing to glow. No flares, no explosions, no warmth. Just mass. Motion. Gravity. If such a cluster passed between us and a visible star field, we might notice strange distortions. Stars might appear to shift. Light might bend in odd ways. But we'd never be able to pinpoint what was causing it. We'd chalk it up to gravitational lensing, dark matter, or instrumental noise. But in reality, it could be an entire hidden system, right there, just invisible. This introduces a terrifying thought, that space might not be as empty as we believe. We like to think of the cosmos as vast and open, mostly filled with emptiness punctuated by glowing points of light. But if there are countless objects out there that don't glow, don't reflect, and don't emit radiation in any detectable form, then the space between the stars might be cluttered with ghosts. Silent giants drifting through the void. Some may be as small as dead brown dwarfs, others the size of suns that never ignited, and maybe even more massive than anything we've ever seen, yet hidden in plain sight. Not because they want to be, but because we don't have the tools to perceive them. Now, let's think about what this means for astronomy as a whole. All of our observations depend on light. Visible, infrared, ultraviolet, radio waves, all of it is just different kinds of light. We build our understanding of the universe based on what shines. We build models of galaxies, dark matter, and black holes using simulations based on visible behaviors. But if there's an entire class of celestial objects that interact only through gravity and mass, then we're not just missing pieces of the puzzle. We're trying to complete the puzzle while missing half the box. And what does this do to our models of galaxy formation? We believe galaxies form around clusters of matter that collapse under gravity, with dark matter acting as scaffolding. But what if some of that scaffolding isn't made of invisible particles? What if it's made of invisible stars? Massive objects with no photosphere, just floating through space, acting as gravitational anchors. That would completely change our understanding of how galaxies are shaped, how stars are born, how matter is distributed, and how cosmic structures evolve. We'd have to rewrite our equations, rethink our theories, and challenge everything we believe about the architecture of the universe. And here's where it gets really wild. If these photosphere-less stars exist in large numbers, it raises a chilling possibility that some of the things we thought were black holes aren't. Think about it. We define black holes as regions of space where gravity is so strong that not even light can escape. But we only know they're there by their gravitational effects on nearby matter and the radiation from the accretion disks that form around them. What if some of these gravitational anomalies aren't black holes at all, but ultramassive, lightless objects that just never emitted light to begin with? They wouldn't have an event horizon. They wouldn't distort space-time to the same extreme. But they'd still be dark. They'd still be massive. And they'd still be invisible to our eyes. Even more unnerving is the idea that some of these invisible objects might be closer than we think. Perhaps one is already within our galactic neighborhood, quietly orbiting, exerting subtle tugs on distant stars or clouds of gas. Maybe it's already been detected, but misclassified as a statistical anomaly or explained away with standard models. Maybe the only thing separating us from a massive, lightless object is our own blindness, our overdependence on light as a measuring tool. We might not need new theories. We might just need new ways of seeing. One idea gaining quiet attention in the astrophysics community is gravitational microlensing. This technique doesn't rely on light coming from the object itself, but instead looks for how its mass bends the light of more distant stars behind it. When a massive object passes in front of a star, it acts like a lens, temporarily magnifying the background light. It's subtle. It's rare. But it's measurable. And in recent years, astronomers have detected microlensing events that don't correspond to any visible object. The light bends. The star brightens. Then nothing. No star. No planet. No black hole. Just something. Something massive. Something invisible. Something that should not be there, but definitely is. And if those microlensing events are happening more often than we expected, then we're forced to consider that there are far more of these invisible objects than anyone imagined. What we once thought of as rare may actually be common but hidden. The silent majority of the universe. And once you entertain that idea, everything else starts to shift. Maybe photosphere-less stars are the rule, not the exception. Maybe shining stars like our sun are just a lucky few, cosmic flukes that happen to ignite. Maybe darkness, not light, is the standard in this universe. This takes us to the concept of detection bias. We tend to think that what we see is what exists. But in reality, what we see is just what our instruments allow us to detect. We've built our entire picture of the cosmos around photons, around what's bright and visible. But what if we're living in a dark universe lit only by the rare spark of occasional stars? That means everything we know, from cosmic background radiation to planetary discovery to the expansion of the universe, could be skewed by a deeply embedded bias toward the visible. We might be trying to draw a complete map of the Earth using only the lighthouses as our landmarks, completely unaware of the mountains, rivers, and cities in the darkness. And if the universe is built on this kind of hidden structure, then we're just scratching the surface of a reality more complex and more bizarre than we ever imagined. There could be entire galaxies made of photosphere-less stars, orbiting each other in silence, never once breaking the dark. There could be star systems composed entirely of non-radiating bodies, with planets orbiting stars that never shine. And those planets, could they harbor life? Could they have evolved beings adapted to live in the absence of light? Entire civilizations growing in the dark, under the gravitational warmth of stars we cannot see? Galaxies come together, evolve, and behave over billions of years. If some of the mass we attribute to dark matter is actually from these invisible stellar bodies, then we've been miscalculating fundamental dynamics of the cosmos. Maybe that explains the strange rotational speeds we see in galaxies. Maybe not all of it is dark matter in the theoretical sense. Maybe some of it is dark matter in the literal sense, real, solid objects that are just dark. Now picture this: two galaxies collide. Stars whip past each other, gravity stretches and pulls, and huge clouds of gas ignite in bursts of new star formation. That's the standard image. But what if, within that collision, there are hundreds, maybe thousands, of unseen stars being flung around? No light. No trace. Just added mass throwing off our measurements. That would mean galactic collisions are far more chaotic than we ever imagined. They might be full of impacts we can't observe, interactions we can't model, and consequences we can't predict. There's also the possibility that these photosphere-less stars could be relics from a past universe. That sounds wild, but stay with me. Some cosmologists theorize that the Big Bang wasn't the beginning of everything, but rather a phase shift, or a bounce, from a previous cycle. If that's true, then maybe not everything from that previous universe was destroyed. Maybe some objects, massive, exotic, and incredibly stable, survived the transition. They wouldn't follow the same rules as the matter we know. They wouldn't glow, they wouldn't fuse hydrogen, and they might not even decay. They just exist. Leftover seeds from a time before time, floating quietly in our current universe. And what if some of these objects aren't even made of matter as we know it? What if they're made of mirror matter, a hypothetical substance that interacts with itself but barely with our regular matter? It's one of the ideas floated in alternative dark matter theories. Mirror stars, made entirely of mirror particles, could go through their own kind of fusion, their own kind of stellar evolution, completely invisible to us. A whole mirrored sky that we just can't see. That would mean we're living in a dual-layered universe. Ours, made of regular matter and stars, and another, ghostly universe made of mirror matter and photosphere-less stars that only interact through gravity. It gets even stranger when you realize we might have already seen the effects of these invisible stars, without knowing it. Astronomers have detected gravitational microlensing events where a star's light briefly brightens due to an unseen object passing in front of it. Most of these are assumed to be rogue planets, or black holes. But what if they're photosphere-less stars? Massive, lightless stars that just pass between us and a background star for a few days, bending its light subtly. We might have already catalogued dozens, or even hundreds, of these events, completely unaware of what we were actually looking at. And now we arrive at a frightening question: what if one of these objects came close to Earth? Not close enough to collide, but close enough to throw off orbits. Disrupt the asteroid belt. Tug at the sun. We wouldn't see it coming. There would be no light, no heat, no signal. Just the aftereffects: planets drifting out of alignment, comets suddenly changing course, tides acting strange. If you really stretch it, some of the chaotic extinction-level events in Earth's past might have been triggered by invisible forces we couldn't name. Not because they were supernatural, but because they were unseeable. And if these objects can disrupt star systems, what happens when they drift into the heart of galaxies? What happens when they get caught in the accretion disks of black holes? Would they feed the black hole like any normal star? Or would they resist, or alter the process somehow? We've seen black holes flicker, pulse, and suddenly brighten. Some think it's due to stars falling in. But maybe sometimes, it's something we can't see, slipping over the event horizon without a whisper. Then there's the question of planetary formation. If photosphere-less stars exist, could they host planets? Could those planets be heated by tidal forces or radioactive decay instead of starlight? Could life exist there, completely cut off from traditional light? Entire biospheres built around geothermal vents, subsurface oceans, and chemical energy? We already see that possibility on moons like Europa and Enceladus. Now imagine whole planetary systems, orbiting dark stars, with civilizations that evolved never seeing a sunrise. If they develop science, would they even understand the concept of light? This introduces one of the most haunting possibilities: that intelligent life might be far more common around stars we can't see than the ones we can. We're scanning the skies for radio signals, flashes of light, or visible megastructures. But if alien civilizations evolved in total darkness, they might communicate through means we haven't even considered. Gravitational waves, neutrino beams, quantum entanglement, all invisible to us, or dismissed as noise. And if that's the case, then the Fermi paradox, the question of, where is everyone? Might have a horrifyingly simple answer: we're looking in the wrong spectrum. We're searching for light, for radio, for things that shine. But most of the universe might not be shiny at all. It might be dark, quiet, and full. Occupy the same space but remain entirely undetectable, except through gravity. If that's true, then every part of our galaxy, every inch of the observable universe, could be overlapping with another version, a ghost universe. Not in another dimension, not in some far-off parallel realm, but right here. Sharing the same space, the same volume. We just don't see it because we're blind to what doesn't emit or reflect light. Now think about how that changes everything. Our search for life, our theories of planetary systems, our measurements of cosmic distances, all of it assumes that what we see is all there is. But if there are entire populations of stars we can't see, then how many planets might be orbiting them? How many systems might be hiding in darkness? Could life exist in those systems? Not life as we know it, because it wouldn't have access to visible light, but maybe something adapted to different kinds of radiation. Or maybe something that evolved to live in total darkness. Life that never had a photosphere to orbit around. Life that evolved around gravitational warmth, magnetic flux, or chemical reactions alone. Here's another possibility. What if these photosphere-less stars aren't entirely natural? What if some of them were made? Not by us, by someone else. Think about how advanced civilizations might try to hide. The Kardashev scale measures civilizations by how much energy they can use. A Type 2 civilization can harness the energy of an entire star. But what if they didn't want to be seen doing it? What if they surrounded their star with a perfect, light-blocking shell, not just a Dyson sphere to harvest energy, but one that completely encloses the star to mask its presence? That would turn an ordinary star into a dark object. No photosphere. No emissions. No signal. Just mass. Just gravity. A technological black box. And if multiple civilizations did this across the galaxy, we could be surrounded by intelligent life that has chosen to go completely dark. They might be watching, listening, recording, while staying utterly invisible. That's a whole new take on the Fermi paradox. Maybe they're not silent because they're not there. Maybe they're silent because they don't want to be found. It also makes you wonder, have we already seen them? Have our telescopes captured tiny gravitational anomalies, unexplained lensing events, strange wobbles and binary systems that didn't make sense, and just written them off? We tend to assume error when something doesn't fit our models. But what if those errors are actually evidence? What if our most confusing data points are the tip of the iceberg, signs of an entire class of objects, structures, or systems we haven't even begun to understand? Photosphere-less stars could also offer answers to long-standing questions in astrophysics. For example, we know about neutron stars, white dwarfs, and black holes, all endpoints of stellar evolution. But what if some stars take a different path? What if some, under specific conditions, collapse not into a neutron star or black hole, but into a stable state that no longer emits light? A dead star with no crust, no light, no magnetism, just gravity. It would be nearly impossible to detect unless it passed directly in front of a background source. And even then, only with extremely precise instruments. That brings us to the strange idea of gravity-only objects, bodies that exist purely in the gravitational domain, with no interaction with the electromagnetic spectrum. Some physicists propose the idea of geons, gravitational electromagnetic entities that are held together by their own energy. Others think about exotic matter configurations that are completely invisible but still massive enough to influence nearby objects. These could be theoretical pathways to real, observable photosphere-less stars, or at least explain how they might come into existence in certain conditions. What if those conditions are common in the early universe? Imagine the first few million years after the Big Bang. A chaotic mess of matter, radiation, and expansion. Maybe some protostars formed too fast or from unstable materials. Maybe some regions cooled in strange ways. If any of those objects skipped the step of ignition, if they never reached the threshold to shine, they could have become these invisible giants. And now, billions of years later, they still exist, drifting through space, undetected. This isn't just theoretical fluff. Scientists have already started picking up hints of dark, star-sized objects via microlensing surveys. These surveys look for brief distortions in background starlight when something massive passes in front of it. Sometimes, these lensing events don't match anything we know. They don't seem to involve stars, planets, or black holes. They suggest compact objects that don't shine, just like a photosphere-less star would behave. The problem is, these events are rare and short-lived. Without consistent data, we can't confirm anything. But they keep happening. Enough that it's getting harder to ignore. So let's say these objects are real. What does that mean for the future of astronomy? It means we need new tools. New kinds of detectors. Instruments that can measure gravity directly, or pick up ultra-faint signals we currently miss. It means rethinking how we scan the sky, not just for what glows, but for what bends, pulls, or distorts. It means admitting that we're still blind to most of what's out there. And maybe, just maybe, it means the universe is way more crowded than we thought. Not with aliens, necessarily, but with mass. With structure. With silent, invisible stars keeping secrets we haven't even thought to ask. Light around seemingly empty regions of space, and just dismiss them? Maybe we cataloged them as glitches, as data errors, or attributed them to dark matter clumps. But what if those anomalies weren't mistakes? What if they were signs? Subtle footprints of something real, something massive, and something hiding in plain sight? And here's where it gets crazier. These photosphere-less stars, if they exist in large enough numbers, could be the missing puzzle piece in multiple cosmic mysteries. For example, we've long puzzled over why certain galaxies appear to be heavier than they should be. We've measured all the visible matter, the stars, gas, and dust. But when we look at how fast stars orbit around the center of those galaxies, the numbers don't match. There's too much mass, more than we can account for. That's one reason scientists propose the existence of dark matter. But what if part of that mass is coming from invisible stars? If hundreds of billions of them are scattered throughout galaxies, masses that don't glow but still exert gravity, they would explain at least part of the discrepancy. And maybe this helps explain galactic cores too. At the heart of nearly every galaxy is a supermassive black hole. But what feeds them? How do they grow so massive so quickly? One idea is that invisible stars, dark, dense, undetectable objects, spiral inward over billions of years, slowly feeding these black holes. Since we can't see these stars, we might be missing the main supply chain that fuels the most powerful engines in the universe. There's also a disturbing possibility. What if some of these invisible stars aren't stars at all, but something in between a star and a black hole? Like failed stars that never ignited fusion but still grew to massive sizes. Imagine objects too small to be full-fledged stars but too massive to be planets. They'd be cold, dark, and wandering through space. They wouldn't emit light, they wouldn't reflect light, and they might only be detectable through the way they bend light around them, via gravitational lensing. And we've already seen strange lensing events. There have been times where a background star suddenly brightens, then fades, for no apparent reason. Astronomers call these microlensing events. They assume a small but massive object passed in front of the distant star, bending its light just enough to amplify it temporarily. We've found some rogue planets this way. But some of these events don't line up with anything we can explain. No object, no star, no planet. Just a spike in brightness, then silence. Could those be photosphere-less stars moving silently between us and deep space? This mystery keeps going deeper. Think about black dwarfs, hypothetical remnants of stars that no longer shine. In theory, a white dwarf will cool down over trillions of years until it becomes a black dwarf, radiating no light, only gravity. Now, we haven't had enough time in the universe for any star to become a black dwarf yet. But what if something accelerated the process? What if there are shortcuts to that final state, through interactions with dark matter, or exotic physics we don't yet understand? That could mean black dwarf-like objects exist now, long before we thought possible. Dark stars, without photospheres, floating in silence. And then there's the idea of boson stars. These are purely theoretical, but mind-blowing. Instead of being made of normal matter, they'd be made of bosons, particles that follow different quantum rules than what make up our atoms. These stars wouldn't emit light in the way we're used to. They might not even have a surface. They'd be like dense, stable clouds of quantum particles held together by gravity. And they could be massive. Massive enough to mimic black holes, without ever collapsing fully. They wouldn't have a photosphere. They might not have any kind of traditional emission at all. But they'd still warp space. They'd still pull objects toward them. And they'd still be completely invisible to all but the most sensitive gravitational detectors. And let's not forget neutron stars, some of the densest objects in the universe. In a way, they already blur the line between visible and invisible. Most of them don't emit visible light. Some are pulsars, beaming radio waves like cosmic lighthouses. But others are completely silent. Cold, dead, dark. They're out there, billions of them. And unless they interact with something, we'll never find them. They're already, for all practical purposes, photosphere-less. So we're stuck with a universe that's more invisible than visible. More hidden than revealed. more silent than speaking. And the deeper we look, the more we realize how little we truly know. Every telescope upgrade, every new space mission, every particle accelerator, it all brings us closer to admitting the same unsettling truth: we might be missing most of what's really out there. Just enough to make it appear brighter for a moment. These microlensing events have been observed all over the sky, and while some can be explained by known objects like rogue planets or stellar remnants, others remain unexplained. Some of them last longer than expected, or occur in areas with no known nearby stars. What if these are the subtle signals of photosphere-less stars passing silently through space? Objects with mass but no glow. And what if we've been looking at these clues for decades, but we never realized what they were? Even more fascinating, some researchers believe these invisible stars could help solve the mystery of dark galaxies, entire galaxies that seem to contain little to no visible stars. These galaxies are detected by how they affect nearby structures or by how they distort background light, but they appear almost completely dark. Traditional theories suggest they might just be filled with gas and dust that never formed stars. But maybe the stars did form, just not the kind we're used to. Maybe these galaxies are filled with stars that never developed a visible photosphere. In other words, they're not empty, they're just hiding. And let's go one level deeper. There's a theory that space itself could be filled with what are called non-luminous baryonic clouds, massive clouds of protons and neutrons that never coalesced into normal stars or planets. If they're large and dense enough, some of these clouds could collapse under their own gravity and form objects that resemble stars but never shine. They would be cold, dense, and completely invisible to our telescopes. And if they make up even a small fraction of the universe's total mass, they could explain why our models keep running into inconsistencies. But here's where the trail leads into even stranger territory. What if some of these photosphere-less stars are ancient? I'm talking pre-galactic, born before the first known stars. Some theories suggest that after the Big Bang, the very first stars, called population 3 stars, formed out of pure hydrogen and helium. But we've never seen one. They were supposed to be massive and short-lived, and yet, none have been detected. But what if some of them didn't burn out like we expected? What if some of them never ignited at all? Imagine ancient, massive objects drifting through the cosmos for over 13 billion years. They would be older than galaxies, older than most known structures in the universe. They would be relics of the universe's childhood, completely dark, completely undetectable except for the way they quietly tug on everything around them. Maybe they'd been drifting through the darkness since before our Milky Way even formed, influencing its structure from the shadows. Maybe they still are. And now imagine this: what if some of those ancient stars collided over the eons, not with each other, but with other cosmic objects? Imagine a cold, photosphere-less star drifting into the path of a rogue black hole. What would happen? Could it be torn apart without a flash of light? Could it silently vanish, without emitting a single photon? That would make it invisible both before and after its destruction. A cosmic event with zero light, purely detectable by its gravitational ripple. It's like the universe has its own ghost stories, and we're only just starting to hear the whispers. And here's a truly wild idea. What if these stars aren't just part of the cosmic furniture, but actually a result of intelligent action? What if an ancient civilization, millions or billions of years more advanced than us, found a way to turn off stars? Not destroy them, just deactivate their photospheres. Hide them. Cloak them. Make them invisible to lower-tech civilizations. Us. If they had the power to manipulate stellar structures, maybe they figured out how to suppress a star's fusion reaction, or trap all its light within a reflective or absorptive shell. Think of it like pulling a cosmic curtain over a light bulb. The light is still on inside, but we'll never see it from the outside. Why would they do that? Maybe it's to protect themselves. Maybe it's to prevent other civilizations from detecting them. Or maybe it's a way of conserving energy. Harvesting a star without the loss of photons. Perfect efficiency. A black star that feeds its creators without giving off any trace. And maybe that's what we've been seeing. Not dead stars. Not failed stars. But controlled stars. Hidden stars. quiet stars. And if that's the case, then we're not alone, we're just not invited to the party. Not yet. Older than planets, older than the very structures we think make up the universe. These ancient, cold giants could be the ghosts of a universe that existed before stars as we know them. They would be silent, invisible witnesses to cosmic history, holding secrets no telescope has ever seen. And if they're out there, they might be far more common than we think. Now consider this: what if photosphere-less stars are not just relics of the past, but also a common product of star formation itself? Maybe not all collapsing gas clouds end up with the right conditions for nuclear fusion. Some might reach a critical mass but never ignite, failing to become traditional stars, and instead becoming these strange, dark versions. And if these objects form regularly throughout cosmic time, they may make up a significant percentage of the total star population, an invisible population hiding in the cosmic dark. We often think of stars as brilliant, blazing bodies lighting up the universe. But what if that's only half the story? What if for every bright star we can see, there's another one that never turned on its light? These dark stars, scattered throughout galaxies, orbiting in clusters, and drifting alone in deep space, could be quietly shaping the universe behind the scenes. They'd be the hidden scaffolding of galaxies, the silent contributors to gravitational fields, the shadows behind the light. Now here's another twist. What if some of these photosphere-less stars are surrounded by exotic matter? The kind of matter that doesn't interact with light at all. Not just dim or cool, but truly invisible. Some physicists suggest the existence of hypothetical particles like axions or sterile neutrinos, which could clump together under the right conditions. If such particles formed massive objects, they wouldn't radiate energy like normal matter. They'd be effectively invisible, not just because they lack a photosphere, but because their very nature is incompatible with light. This isn't just science fiction. These ideas are being explored in real physics papers, by real researchers, using real math. And it's starting to raise real questions about how much of the universe is hidden from us. We've always assumed that what we can't see, we can't study, but with gravitational lensing, radio waves, neutrino detectors, and future observatories like the Nancy Grace Roman Space Telescope, we may soon be able to detect the gravitational fingerprints of these ghostly giants. And if we do find them, photosphere-less stars, cold stellar remnants, invisible behemoths, then we'll have to rewrite much of what we thought we knew about space. Our catalogs of stars, our models of galaxy formation, even our understanding of gravity and mass, it could all change. Because the moment we realize that half the stars in the universe are hiding, we'll finally be forced to admit something. We've been staring into the light, while the truth was waiting in the dark. And when that happens, it could completely rewrite what we think we know about the universe. Imagine this for a second. Let's say we discover that these photosphere-less stars are as common as regular stars, maybe even more common. That would mean that for every blazing sun we see lighting up the galaxy, there's another one drifting silently through space, completely invisible to the naked eye and even to our most sensitive instruments. It would change the way we calculate galactic mass. It would change the way we understand star formation. It would flip our models of the universe upside down. Suddenly, the so-called missing matter wouldn't be missing at all. It would be hiding in plain sight, only invisible to the spectrum of light we've always relied on. That single realization would make scientists revisit every theory built on the assumption that we can see all, or even most, of what's out there. It would mean that our telescopes have been showing us just a fragment of reality, a tiny sliver of the universe's true complexity. And if you think that's already wild, think about what this could mean for our understanding of dark matter. For decades, scientists have known that galaxies behave as if there's more mass in them than we can account for. Stars orbit the center of galaxies at speeds that don't make sense unless there's some unseen gravitational force keeping them from flying off into space. So we came up with the concept of dark matter, an invisible substance that doesn't emit or absorb light but has mass and therefore exerts gravity. But what if some portion of that dark matter is actually just matter we failed to detect because it lacks a photosphere? In other words, what if dark matter isn't all exotic or unknown? What if part of it is made up of normal matter, just hidden in the form of non-glowing, unlit stars. This brings us to a fascinating intersection between astrophysics and cosmology. We know that baryonic matter, normal matter made of protons and neutrons, only accounts for a small percentage of the universe's mass energy content. But we also know that not all baryonic matter is visible. Some is locked up in cold gas, dust, and possibly in these unseen stars. If photosphere-less stars turn out to be widespread, then maybe we've severely underestimated how much of the universe's missing baryons are actually in the form of non-luminous stellar objects. That would not only help close the gap in our models, it would also mean that we've been looking in the wrong direction all along. Now let's talk about the implications for exoplanetary science. If these stars exist without a photosphere, then any planets orbiting them would be extremely difficult to detect. Most exoplanet detection methods rely on light, either from the star being dimmed when a planet passes in front of it, or from the star wobbling slightly due to the planet's gravitational pull. But if a star has no photosphere, there's no light to dim, and potentially very little light to observe its wobble. This means entire solar systems could be out there, completely hidden. Planets orbiting invisible stars. Moons orbiting invisible planets. And maybe, just maybe, life evolving in places we could never imagine, completely undetectable to us right now. These would be the ultimate dark systems, and they could be incredibly common. Our entire catalog of known exoplanets could be just a tiny fraction of what's really out there. And if that doesn't blow your mind, think about what this does to our search for alien life. We've spent decades scanning the skies for radio signals and looking for biosignatures on faraway planets. But if civilizations are orbiting photosphere-less stars, their solar systems might be undetectable to our current instruments. We might have been looking right past them without realizing it. Entire advanced civilizations could be thriving in star systems that emit no light, hiding from view not because they're trying to, but simply because the very stars they orbit don't glow. It's possible that our entire approach to finding extraterrestrial life is fundamentally flawed, simply because we've built it on the assumption that light equals presence. And this brings us full circle, because this isn't just about stars that don't shine. It's about the limits of human perception. For all our telescopes, satellites, and sensors, we are still deeply tied to the idea that what we can see is all there is. The concept of photosphere-less stars forces us to confront a deep truth. The universe doesn't owe us visibility. Just because something doesn't shine doesn't mean it isn't there. Just because something doesn't announce its presence with light doesn't mean it isn't influencing everything around it. In fact, some of the most powerful forces in the universe, gravity, time, space itself, are invisible. Maybe these dark stars are just another reminder that the universe is under no obligation to make itself easy to understand. And think about this. What if we've already observed them, countless times, and just didn't know it? What if those strange microlensing events, those odd radio bursts, those unexplained gravitational anomalies, all had something to do with these invisible giants? What if some of the weirdest, most unexplainable signals we've ever received came not from black holes or neutron stars, but from something much quieter, something less violent, but just as massive? Something that's been right there in front of us the whole time, are actually hiding in these silent, invisible objects. Think about the implications of that. It would mean that the mystery of missing baryonic matter, a puzzle that has baffled scientists for decades, might have been right under our noses this whole time. Or rather, right in front of our telescopes, but invisible to them. All the while, we've been staring out into the night sky, watching the bright dots and thinking we were seeing the full picture, when in reality, we were only seeing the surface of something far more vast, far more complex, and far more hauntingly empty than we imagined. And here's something else to consider. What if photosphere-less stars are not only common but part of an evolutionary pathway in the life cycle of stars? Traditionally, we think of stars forming from clouds of gas and dust, eventually igniting nuclear fusion in their cores and producing the visible light we associate with stars. But maybe that's just one of many outcomes. Maybe some gas clouds collapse and never reach the pressure and temperature needed for ignition. Maybe they get close but fall just short. They'd still be massive, still be dense, still have gravity, but no fusion, no light. They'd be failed stars, dark suns drifting in the cosmic void. And over billions of years, they could cool and shrink, forming objects that are nearly impossible to detect unless they pass in front of a background star or lens distant light with their gravity. And those aren't the only ways these things could form. Consider ancient stellar remnants, white dwarfs, neutron stars, even black dwarfs. We know that white dwarfs slowly cool over time, eventually becoming so cold that they no longer emit any meaningful radiation. But the universe isn't old enough for any white dwarf to have reached that stage yet. That's what makes the idea of black dwarfs so fascinating. They're theoretical objects that will exist in the distant future but don't yet exist today. Or do they? What if some of the photosphere-less stars we theorize about aren't failed stars or exotic matter clumps, but ultra-old white dwarfs from an earlier universe or some unknown cosmological event? Their temperatures would be so low and their emissions so faint, they'd be virtually undetectable. Yet their mass, their gravitational influence, would be just as real as that of any burning sun. This leads into some wild, but not entirely implausible, ideas. If our universe had a predecessor, if there was a cosmic cycle of birth and death, as some bouncing cosmology theories suggest, then maybe relics from that previous iteration survived the transition. Maybe they didn't evaporate in the Big Bang. Maybe they were just left behind. Objects so cold, so dark, and so alien that we've never noticed them. Photosphere-less stars, then, could be artifacts of a pre-Big Bang reality, fossils from before time as we know it. And if that's true, then studying them wouldn't just reveal new insights into stars or galaxies. It would be our first direct window into a universe older than our own. Now pause for a second and imagine just how humbling that is. We walk around thinking we understand the universe. We've sent telescopes into orbit, landed rovers on other planets, mapped the cosmic microwave background, and even detected gravitational waves. But all of that knowledge is built on a foundation of light, what we can see, what we can detect. If there are entire classes of objects that don't emit light, or don't have a photosphere to emit light from, then it means we've been building models based on incomplete data. It would be like trying to understand a forest by only looking at the leaves and never realizing there are roots underground. And there's even more to explore. What if these photosphere-less stars have planets orbiting them? Think about that. In our search for exoplanets, we rely on two main detection methods: the transit method, where a planet blocks light from its star, and the radial velocity method, where a planet's gravity causes a star to wobble. But if the host star doesn't emit light, we can't use the transit method. And if the star's signal is too faint or non-existent, we can't use radial velocity either. That means entire solar systems could be hiding in the dark, invisible not because they're far away, but because their suns never lit up. These rogue systems could be orbiting photosphere-less stars, circling silently through the galaxy, completely hidden from every method we use to find them. It's a thought that completely changes the way we think about the abundance of life. We assume that life needs a sun, and that alien civilizations would emerge on planets orbiting bright stars. But what if intelligent life evolved around one of these dark stars? What if they adapted to infrared or geothermal energy, or developed in complete darkness, never needing light at all? Such civilizations would be hidden from our detection methods. They wouldn't send signals in visible wavelengths, and we wouldn't even know where to look. From their perspective, the universe might be just as mysterious and unseen as it is to us. Maybe they'd even built technologies we can't begin to imagine, adapted to an environment completely different from our own. And here's something even more eerie. What if some of these dark stars aren't just stars, but something more? What if they host phenomena we've never seen before because we've never had the chance to observe them in action? Maybe they don't just lack a photosphere, they interact with space-time itself in strange ways. Maybe they distort gravity unusually, or bend light so subtly we've misinterpreted their presence entirely. Some researchers have even speculated about objects called gravity-only stars, which would appear similar to stars gravitationally, but have no electromagnetic signature at all. If they exist, they could be part of a whole new class of celestial objects, one that exists in a parallel branch of astrophysics we've barely begun to explore. The truth is, We don't know how much we don't know. Every discovery we make opens up 10 more questions. And when it comes to the dark parts of the universe, the invisible matter, the unlit stars, the silent structures drifting between galaxies, we're just scratching the surface. Photosphere-less stars might be the key to unlocking that mystery. They might be the missing piece that explains everything from galactic rotation curves to the early formation of cosmic structures. They might even force us to question the very nature of what a star is. Mind-bending territory. What if some of these photosphere-less stars aren't just leftover relics of our universe, but remnants of another? Think about it. If our universe is just one in a potentially infinite multiverse, or even a cyclic universe where time and space repeat through cosmic bounces, then maybe these dark stars are fossils from a previous cosmic cycle. They might not shine, not because they failed to ignite, but because they already burned once in a universe that came before ours. The idea sounds like science fiction, but the more we look into the nature of time, entropy, and cosmic evolution, the more plausible it starts to seem. These stars would be like ghosts, silent, massive, ancient beyond comprehension, drifting through our reality without interacting in any way we can measure, except perhaps gravity. And gravity is key here. Because even if they have no light, they still have mass. They still bend space-time. That means they can still affect the orbits of visible stars, warp the path of traveling light, or even tug on galaxies subtly enough to reveal their presence. In fact, one of the most promising ways to detect these objects is through something called gravitational microlensing. This is when a massive object, like a star, planet, or even an invisible dark object, passes in front of a more distant star. The massive object's gravity bends the light from the background star, temporarily magnifying it. It's subtle, rare, and hard to catch, but when it happens, it can tell us a lot. If we start to find more and more microlensing events with no corresponding visible object, we could be looking at indirect evidence for photosphere-less stars. But here's where it gets even crazier. Because if there are entire populations of stars without photospheres, that opens the door to a possibility even more eerie, that entire civilizations or solar systems might exist in the shadows, orbiting around stars we can't see. These systems would be practically invisible to us. No starlight to reflect off their planets. No light signatures to analyze. Just cold, dark systems moving silently through the galaxy. If intelligent life evolved in one of these places, they might think of themselves as living in a naturally dim universe, never knowing that other parts of the cosmos are lit up with blazing suns. And from our perspective, they'd be completely hidden. They could have entire technologies, entire histories, and we'd have no way of detecting them, unless they wanted us to. And maybe they do want us to. Maybe the strange signals we've occasionally detected, the so-called wow signal, or unexplained radio bursts, are echoes from these hidden systems. Maybe they've figured out how to use gravitational manipulation instead of electromagnetic waves, because light is useless in their world. Maybe their whole understanding of physics is different, built around mass and motion rather than light and heat. And maybe our failure to detect them isn't just because we haven't looked hard enough, but because we've been looking in entirely the wrong way. We've been obsessed with finding planets in the habitable zone of bright, visible stars. But what if the real action is happening around stars we can't even see? Now pull back for a second and realize what this really means. The observable universe, the part we can see with telescopes and instruments, is just a fraction of what's actually out there. We've always known that, to some extent. Dark matter, dark energy, the limits of light's speed, it's all taught us that we're missing most of the cosmic puzzle. But photosphere-less stars add a whole new layer to the mystery. They're not just exotic objects. They're proof that we've barely scratched the surface. They could outnumber visible stars. They could account for mass we've labeled dark. They could host planets, even life. And yet, they drift silently, unknowable, just beyond the edge of perception. It's a chilling idea. Not just because it makes us question everything we know, but because it forces us to realize how blind we really are. Our best instruments, our biggest telescopes, our most advanced theories, they all rely on light. We study the universe through what shines. But what about what doesn't? What about the vast cosmic shadows that hide between the beams of light we measure? What about the hidden scaffolding of the universe, made of mass that never glows? If photosphere-less stars are real, and many scientists now think they are, then we've been peering into the abyss with a flashlight, never realizing that the biggest shapes in the darkness don't reflect any light at all. And this brings us back to one final point: the fragility of human perception. We evolved to see light. We built our science on what we could observe. But the universe doesn't care about what we can see. It just is. And some of its most incredible secrets are likely hiding in the places we never thought to look. Maybe the next revolution in astronomy won't come from building a bigger telescope. Maybe it'll come from learning to see the invisible. Maybe, just maybe, the answers have been waiting for us all along, in the dark. And if you really let that idea settle in, civilizations orbiting stars we cannot see, it opens up a whole new category of the Fermi paradox. Maybe we haven't found alien life because we're not even looking in the right places. Our methods of detection are biased toward light. We search for exoplanets by the dimming of stars, we listen for radio signals, and we analyze spectral fingerprints. But what if entire sectors of our galaxy are filled with dark, cold systems that don't register on any of our instruments? What if advanced alien civilizations have evolved around photosphere-less stars, never needing or using visible light, possibly developing technologies based on heat gradients, magnetic fields, or gravitational wave manipulation? These civilizations could be millions of years old, thriving in conditions we would consider utterly inhospitable, simply because they never relied on sunlight the way we do. Now, think about what that means for exploration. The things we dream about, colonizing new star systems, sending probes to distant worlds, are all focused on the stars we can see. But if there's a whole hidden population of stars, we're missing a huge part of the map. It's like having a world atlas that only shows the cities with streetlights and ignores everything in the dark. There could be entire galactic highways, entire communities of civilizations, trade networks, or even ancient ruins drifting between these photosphere-less stars, and we'd have no clue. Maybe the greatest secrets of the universe aren't hiding behind cosmic veils or in other dimensions. They're just not reflecting any light. This also forces us to reconsider what we mean when we say, dark matter. What if part of what we classify as dark matter isn't actually exotic particles or undiscovered forces, but simply normal matter that emits no light? It sounds almost too simple, but simplicity often hides the deepest truths. For decades, scientists have wrestled with the discrepancy between the visible mass in galaxies and the gravitational effects we observe. Stars move too fast, galaxies rotate too quickly, and entire galaxy clusters seem to be held together by unseen forces. What if part of that mystery is explained not by an invisible new particle but by massive objects we've overlooked? Dead stars, collapsed systems, or even full-blown photosphere-less giants lurking in the darkness. Let's talk about those giants for a moment. Because not all stars are the same. Some are small and faint, like red dwarfs. Others are enormous, blue giants, red supergiants, hypergiants, stars that dwarf our sun in size and power. So what happens if one of those massive stars somehow forms without ever igniting fusion? Or what if it forms with such dense, thick outer layers that the photosphere is never visible? These wouldn't just be hard to detect. They'd be completely invisible unless they passed directly in front of something else. And their gravity would be enormous. We might detect them through gravitational lensing or by watching their subtle influence on the stars around them, but otherwise they'd be ghosts. Think about that, a star the size of Betelgeuse or Antares, hundreds of times bigger than the Sun, but totally black to our eyes. No glow. No heat signature. Just silent mass. If such stars exist, and many astrophysicists now believe they might, they'd pose serious challenges to our models of stellar formation. Our current understanding is built around nuclear fusion as the defining process that gives a star its energy and structure. No fusion, no star. But maybe that's not the whole story. Maybe there are alternative forms of equilibrium that can hold a massive ball of gas together without fusion. Degenerate matter, exotic states of quantum pressure, or unknown interactions that only occur at certain densities. We've seen hints of these ideas in white dwarfs and neutron stars, where quantum mechanics holds up matter in ways we barely understand. So why couldn't a similar mechanism allow a massive, dark, invisible star to exist, stable for billions of years, without ever shining? This brings us to another fascinating aspect. What if photosphere-less stars aren't just natural, but engineered? Imagine a civilization so advanced, it could construct a Dyson sphere, or even a Dyson swarm, a collection of structures orbiting a star to capture its energy. Such a system could potentially enclose a star completely, blocking all light from escaping. From the outside, it would appear as a black void with immense mass. If this idea sounds familiar, that's because it gained traction when astronomers observed Tabby's star, a star whose light dimmed in strange, irregular patterns. While the most likely explanation turned out to be dust clouds, the idea of megastructures lingered. If some advanced race wanted to harness the full energy of a star without broadcasting its location, this would be the perfect method. From our point of view, it would be a photosphere-less star. Not because it failed, but because it was deliberately hidden. Now imagine this happening on a galactic scale. Civilizations that rise, build, and eventually vanish, leaving behind dark, hidden stars cloaked in engineered shells. A cosmic graveyard of forgotten empires. How many of those invisible stars out there are natural, and how many are ancient monuments to a kind of intelligence we can't even comprehend? This thought adds a layer of awe, and maybe a little dread, to our exploration of the unknown. Because it means the darkness might not just be empty space. It might be full of stories, secrets, and shadows of beings who walk their own paths under suns that never shone. Some are massive and live fast, dying in violent explosions. But then there are stars that, from the moment they formed, were destined to be different. Imagine a star that forms in an environment so choked with dust and gas that its light never makes it out. A protostar that, instead of igniting into a familiar blaze, is smothered by its surroundings, blanketed in layers so thick that photons can't escape. This object could still burn on the inside, still go through nuclear fusion, still warp time and space with its mass, but to an outside observer, it would be as black as the void around it. Or maybe, just maybe, it never ignited at all. Maybe it exists in a perfect balance between gravitational collapse and thermal pressure without ever producing the visible radiation that makes a typical star shine. These theoretical bodies might resemble what some researchers call black dwarfs, or even failed stars, but they wouldn't be the same. Black dwarfs are the hypothetical end state of white dwarfs, so ancient that they've cooled to the point where they emit virtually no heat or light. But those are remnants. What we're talking about could be stars that never emitted light to begin with, objects that form and live entirely outside the framework of our traditional stellar evolution. They could exist in dark nebulae, the deep cores of globular clusters, or even on the periphery of galaxies where conditions are extreme and chaotic. And if they're out there, they're not just astrophysical curiosities, they're huge missing pieces in the puzzle of how the universe actually works. We often say that we know what stars are, that they are giant balls of hydrogen and helium fusing in their cores. But the truth is, that's a simplification. The universe doesn't follow our textbooks. It's wild and untamed, and it doesn't care about fitting into neat categories. So maybe there's an entire class of objects we've mislabeled or overlooked because they don't fit the mold. Maybe these photosphere-less stars are the missing evolutionary branches in the tree of cosmic formation. Some might be bridges between stars and black holes, objects so massive and so compact that their gravity almost traps light, but not quite. Others might be ancient leftovers from the early universe, made from primordial matter before the rules of fusion as we understand them took hold. In that case, they're not just rare, they're relics of a time we'll never be able to observe directly. And if some of these dark stars are older than the visible universe itself, older than the first galaxies, older than the cosmic microwave background, then they hold secrets that go beyond astrophysics. They might hold evidence of what the universe was like before the Big Bang. They might contain quantum scars from earlier cosmic bounces, frozen in their internal structure. They might even contain types of matter that no longer exist elsewhere, strange quark matter, exotic boson condensates, or particles not predicted by the standard model. These aren't just interesting ideas, they're potentially testable. If we can detect one of these objects directly or observe how it interacts gravitationally with its environment, we might unlock knowledge that redefines physics itself. But how do we find them? That's the billion-dollar question. Without visible light, we have to rely on other forces. Gravitational waves offer one path. When two massive objects spiral into each other, they release ripples in space-time. We've already detected such waves from black hole mergers and neutron-star collisions. But what if two photosphere-less stars merged? The signal might look different, less energetic in electromagnetic radiation but still potent in gravitational waves. Or perhaps their gravitational signatures could be teased out through long-term sky surveys, tracking the subtle motions of nearby stars and watching for anomalies, like stars whose orbits wobble slightly with no visible cause. Over time, we might piece together a map of the invisible by looking at what it pulls. And then there's the possibility of neutrino detection. Unlike photons, neutrinos pass through matter almost effortlessly. If some of these objects do have fusion reactions deep within, or if they're interacting with dark matter in unusual ways, they might emit neutrinos. These could be detected by massive underground observatories like Super Candy or IceCube. Even just a few anomalous readings could open up a whole new field of research. And who knows? Maybe these dark stars have been pinging us with neutrino signatures for decades, and we've just dismissed them as background noise. Now let's push this even further. What if these stars are more than just astrophysical oddities? What if they're habitats? Not natural ones, artificial. Imagine a civilization so advanced, it built a Dyson-like structure around a black dwarf, or a failed star. But instead of harvesting light, it harvests gravity or magnetic flux or something else entirely. From our point of view, this structure would be invisible. It wouldn't reflect light, wouldn't radiate heat. It would be the perfect cloaking device, not through trickery, but through the laws of nature itself. And if such structures exist, then some of the dark matter we observe might actually be dark technology, artifacts so advanced we can't distinguish them from natural phenomena. And suddenly, the universe feels even lonelier and more crowded at the same time. Because for every star we see lighting up the sky, there might be 10, 100, or even 1,000 others hidden in the dark. And around each one, the possibility of life, thought, and history. A silent galactic web of unseen worlds, waiting for us to evolve enough to notice them. Older than light itself, formed in the dark corners of the cosmos before galaxies even had time to spiral into shape. If such stars exist, they might carry with them traces of physics that predates our current understanding. Think about it. Before stars lit up the sky, before light could travel freely through space, the universe was opaque, dense, and alien. Something must have existed in that epoch. Something must have held mass, exerted gravity, and shaped the cosmic scaffolding we now see in large-scale structure maps. Photosphere-less stars might be those primordial ghosts, survivors of an ancient universe that still linger, not because they shine, but because they endure. These could be relics of a time when the rules were different, when dark matter and dark energy weren't just labels on a chart, but dominant forces that dictated everything. And what if we've already seen them? What if buried deep in astronomical data, in anomalies we brushed off as sensor errors or background noise, there are hints, faint gravitational lensing effects without a visible source, mysterious heat signatures from the void, or subtle patterns in the movement of nearby celestial bodies that suggest an unseen mass pulling the strings. Astronomers have occasionally observed stars moving in odd orbits, curving unexpectedly, behaving as though something massive and invisible is tugging at them. In most cases, they blame black holes or dark matter, but maybe, just maybe, it's a star with no photosphere. Not dead. Not collapsed. Just silent. And the implications of that are massive. Because if we start confirming the existence of these kinds of stars, it means our census of the universe is off by potentially trillions of objects. That means recalculating how much mass exists in every galaxy. That means reworking stellar evolution models from the ground up. And most importantly, that means we've been making all of our cosmic guesses about age, expansion, density, based on an incomplete picture. It's like trying to figure out the population of a city by counting only the people who scream. Now here's where it gets even crazier. A star that doesn't emit light is basically invisible in the optical range. But what if we stop limiting ourselves to visible light? What if we begin to design instruments that look for stars in gravitational waves or neutrino emissions? Because even if a star doesn't shine, if it's undergoing fusion or producing intense gravity, it's still interacting with its environment. A star with no photosphere might still produce intense magnetic fields. It might influence the spin of nearby pulsars or distort the path of interstellar dust in strange ways. In fact, some researchers are now proposing missions specifically designed to map gravitational anomalies, to identify mass without light. These projects, while still early stage, are exactly the kind of thinking we need if we ever hope to map the true landscape of the cosmos. But let's go one step further, because you have to ask, if these stars exist, then what about planets around them? Could there be solar systems orbiting invisible stars? Entire planetary systems suspended in the void, revolving around a mass that gives no light? That's not just science fiction, that's potentially real. And planets in these systems would be radically different. No sunlight. No day and night. Just the cold, ambient heat of the parent star's mass. Life there, if it exists, would have to evolve based on completely different rules. Biochemistry might rely on geothermal energy, or even direct magnetic interactions. Civilizations could develop without ever seeing a star in the sky. Without ever developing vision as we know it. And here's the eerie thought, if we ever encountered signals from such a civilization, would we even recognize them? Would they use light or radio at all? Or would their communication be based on gravity waves, magnetic pulses, or quantum entanglement, forms of transmission we're not even listening for? We've assumed that light is the universal constant of intelligent life, because it's the one that shaped us. But maybe for most of the universe, it's the exception. It's still doing something. It's still reacting. It's still radiating energy, just not in the way we're used to detecting. Imagine a star that exists in a state of constant nuclear tension, fusing elements deep within but shrouded in such a thick shell of matter that the energy gets trapped, degraded, or diffused into wavelengths we're not currently looking for. It could be radiating in the extreme microwave or gamma ray bands, or perhaps it's surrounded by so much dust and gas that any energy escaping is completely reabsorbed by the surrounding environment, heating that dust slightly and giving off the weakest, faintest infrared signals. These could be interpreted as ambient heat signatures or background noise in current datasets, dismissed as minor fluctuations rather than the signatures of entire hidden stars. We've already seen glimpses of strange objects in the cosmos that don't quite fit our categories. Massive compact halo objects, or machos, detected via gravitational microlensing, rogue planets that don't orbit any star but wander the galaxy alone, or ultra-diffuse galaxies that somehow maintain structure without any apparent light-emitting sources. Maybe some of these anomalies are connected. Maybe we've been seeing the outlines of photosphere-less stars without realizing it. These stars might not just be individual anomalies. They could be components of entire populations of dark stellar objects that have gone undetected not because they're rare, but because we never knew to look for them. Our eyes have been blinded by light, and in doing so, we might have missed the hidden skeletons of galaxies. Think about the technological revolution that would unfold if we began detecting these objects. It would be like suddenly discovering a second, invisible layer of the universe. New surveys would be launched with instruments specifically tuned to hunt for gravitational signatures, temperature anomalies, neutrino emissions, or ultra-long radio waves. New theories would be written to explain how a star could burn without shining. And new debates would erupt. Are these objects a new class of star, or something older and more fundamental? Are they evidence of early cosmic conditions that no longer exist? Or are they the product of environments so extreme that light simply doesn't escape? Some physicists have floated ideas about quasi-stars, massive bodies in the early universe that may have formed with black holes at their cores, surrounded by an envelope of gas so dense that they glowed only faintly, if at all. These quasi-stars were theoretical answers to how supermassive black holes could have formed so quickly after the Big Bang. But what if quasi-stars weren't just a short-lived early universe phenomenon? What if they're still around in some form, cloaked in layers of gas, almost completely dark, and dotting the universe like hidden fortresses of mass and energy? They wouldn't look like stars. They wouldn't behave like stars. But they'd still hold enough mass to shape their environment. They'd still pull on nearby bodies. They'd still act like anchors in space-time, silently influencing everything around them while remaining invisible to traditional telescopes. And here's where things get truly mind-bending. What if some of these photosphere-less stars aren't naturally occurring at all? What if some are artificial? If a civilization wanted to hide its energy usage, to mask itself from being detected, wouldn't cloaking their stellar output be the ultimate camouflage? A civilization advanced enough to manipulate stellar structure could theoretically construct a star whose radiation never leaves its envelope. It would be a kind of cosmic stealth mode. No photons to give away your position, no flares, no pulses. Just a gravity well with no glow. In the search for extraterrestrial intelligence, we've focused heavily on listening for signals, watching for megastructures, scanning for radio transmissions. But maybe the most advanced civilizations don't send out messages. They erase their shadows. They turn their stars dark. And if they did that, we might be looking right at them and never know. And those quasi-stars may be the missing link between our understanding of photosphere-less stars and the earliest epochs of cosmic history. Unlike the stars we're familiar with, stars that radiate energy freely from a well-defined photosphere, quasi-stars could have had such intense gravitational fields and such high internal pressures that their energy was trapped for millions of years, leaking out only as slow, low-level radiation invisible to our current telescopes. These were not failed stars or dying stars. They were something else entirely. Stars that burned but never glowed, stars that consumed themselves from the inside out without ever announcing their existence to the universe in visible light. If photosphere-less stars are their modern descendants or perhaps evolved versions of these primordial beasts, then we may have completely misunderstood how stellar evolution can unfold under certain circumstances. Imagine a massive cloud of gas collapsing not into a conventional star, but into a core so dense that it forms a miniature black hole surrounded by a turbulent envelope of matter. That envelope could be thick enough to trap photons for thousands, or even millions of years. If such a structure stabilizes, and doesn't immediately collapse into a singularity, it could operate in a liminal space between star and black hole. That's a quasi-star. And what if that envelope eventually cools, but the black hole remains, still accreting, still radiating faintly in a way we haven't figured out how to observe? What if some quasi-stars never fully collapse but remain suspended in that strange state for billions of years? These would be the ancestors of today's photosphere-less stars, silent, ancient, and undetectable by any normal means. And here's where it becomes mind-bending. If these objects are real, and there's increasing theoretical support that they could be, then they might vastly outnumber visible stars. Think of every dark patch in the sky, every void between galaxies, every empty halo surrounding clusters. What if those regions aren't truly empty? What if they're teeming with hidden stars, unseen giants that lurk in silence? The implications for dark matter are massive. For years, scientists have tried to pin down what dark matter is. Some have speculated it's made of WIMPs, weakly interacting massive particles. Others think it's axions, or even primordial black holes. But what if part of the dark matter problem is actually a miscount? What if a sizable fraction of dark matter is not matter we don't understand, but matter we've simply failed to see? What if it's made of countless photosphere-less stars, objects that don't emit light, don't register on optical surveys, and don't behave in any way we normally associate with starlight? This is a paradigm-shifting idea. It challenges the foundational assumptions we use to calculate cosmic mass, map gravitational fields, and understand galactic formation. If these objects are out there, lurking invisibly in halos and voids, then we've been building our models of the universe on incomplete data. And that means everything, from the age of the universe, to the rate of its expansion, to the way galaxies cluster, could be wrong. We may be living in a cosmos not just darker than we thought, but far more crowded. And if that weren't enough, there's a wild possibility that connects all of this to the deepest mysteries of astrophysics: black holes. Think about it. The boundary between a photosphere-less star and a black hole might be thinner than we've imagined. If these stars are so massive and dense that they trap all their light internally, how do we distinguish them from black holes in practice? They both bend light, both exert powerful gravitational effects, both emit little to no visible radiation. Could some of the black holes we've catalogued actually be extreme versions of these invisible stars? Stars that appear as black holes only because we lack the resolution to see their subtle emissions? Or could they be predecessors, cosmic objects that evolve into black holes not by collapse, but by starvation, by slowly burning down their own mass in total darkness? Matter isn't exotic particles at all, but ordinary matter in an extraordinary state. These hidden stars that don't emit light the way we expect? If photosphere-less stars are out there in vast numbers, they could contribute mass to galaxies without contributing light, perfectly mimicking the gravitational effects we've been attributing to dark matter. This wouldn't solve the dark matter problem entirely, of course. There's still too much missing mass to account for just with hidden baryonic objects, but it could significantly shift the numbers. It could mean that we've been misled by our own expectations, building a model of the universe that depends too much on what we can see, and not enough on what we can infer. It's also possible that some of these hidden stars were once normal stars, stars that, over billions of years, collapsed or evolved into new forms. Stars that consumed their own outer layers, or were stripped bare by galactic collisions, or that merged with neutron stars or black holes in such a way that they were cloaked in matter so thick and so dense that even the energy from their violent rebirths couldn't escape. Over time, these cloaked objects would cool, their emissions dropping lower and lower on the electromagnetic spectrum until they effectively disappeared from view. But their mass would remain. Their gravity would still affect nearby stars. And if they were in binary systems, they might tug visibly on their companions. These tugs, tiny, rhythmic wobbles, could be the only signs of their existence. And maybe we've already seen those signs and just didn't realize what we were looking at. There's a term used in astronomy: failed detections. These are the anomalies, the outliers, the unexplained gravitational lensing events, the stars that flicker oddly for no clear reason, the voids where something should be but isn't. Over the past few decades, these have piled up quietly in data logs and spreadsheets. Researchers often write them off, assume they're instrument noise, data errors, or flukes. But what if they aren't? What if we've been staring at the fingerprints of photosphere-less stars all along? But because they don't emit light, we never thought to call them stars. And the theoretical groundwork is starting to appear. Physicists and astrophysicists have begun modeling objects with no clear photosphere, objects that might radiate only in neutrinos, or that emit such long wavelength radiation that only the most sensitive detectors can pick them up. There are even speculative ideas that these objects could interact with dark energy, or exist in higher dimensional folds of spacetime, where part of their emission is bled off into other dimensions. That's far from confirmed, but the fact that we're even asking these questions shows just how far the concept of a star has stretched. 100 years ago, a star was just a point of light in the sky. Today, it might be a hidden engine burning in silence somewhere in the void, bending space but not lighting it. And here's another wild angle: if photosphere-less stars are real, could life evolve around them? We usually assume life needs a sun-like star to provide warmth and light. But what if there are forms of life that don't need visible light at all? What if an advanced civilization found a way to build habitats around one of these objects, harnessing its gravitational energy, or its neutrino output? It sounds like science fiction, but consider this: our planet's deep ocean vents are home to entire ecosystems that never see the sun. They live off the heat and chemicals from Earth's interior. Maybe somewhere in the universe, in the shadow of a lightless star, something similar is happening. And then there's the technological implications. If we ever develop the capability to detect and study these objects directly, through gravitational wave astronomy, neutrino detectors, or space-based infrared telescopes of unprecedented sensitivity, we'd be opening a whole new window on the universe. Suddenly, we wouldn't just be looking at what glows. We'd be mapping the skeleton of the cosmos. We'd see the gravitational scaffolding, the invisible anchors, the dark infrastructure that holds galaxies together. Photosphere-less stars might be the missing data layer, the dark ink in which the real story of the universe is written. But until then, we're still mostly blind. The search for these objects is like trying to find the wind by looking for movement in the grass. You don't see the thing itself, only what it does to everything around it. And that makes them frustrating, elusive, and deeply compelling. Because if they do exist, they'll change everything we thought we knew about the life cycle of stars, the structure of galaxies, and the nature of cosmic evolution itself. In neutrinos, gravitational waves, or extremely low-frequency infrared radiation, these emissions would be almost impossible to detect with current technology, especially if the star were light years away or buried deep inside a dense region of space. In simulations, these objects still behave like stars in terms of mass and internal fusion, but because of the nature of their outer layers, either due to their composition, density, or surrounding material, they don't have a surface that glows like our sun does. Instead of a visible photosphere where light is released, the radiation gets absorbed, scattered, or trapped beneath layers of dense gas, magnetic fields, or perhaps even exotic matter. And here's where it gets even more wild. If the matter surrounding these stars is made of something we don't yet fully understand, like a superfluid plasma or matter under intense magnetic pressure, it could change the way energy escapes entirely. It could smother light before it ever gets out. Some theories even suggest these objects might be cloaked in a type of dark matter shell, having formed in regions of space where dark matter density was unusually high. In such cases, energy would leak out in unobservable ways, and even gravitational waves might be subtly warped by the strange properties of that outer layer. Now think about how much of the universe is invisible to us. Around 85% of all matter is estimated to be dark. That doesn't just mean dark as in we can't see it. It means it doesn't emit or absorb light in any way we can currently detect. But it does interact through gravity. That's how we even know it's there. What if many of these so-called dark clumps of matter aren't mysterious particles, but entire populations of photosphere-less stars, floating unseen between galaxies, or hanging in the halos of galaxies like ghosts of the early universe? And that opens up another layer of mystery. Could these hidden stars harbor planets? Could they have systems? Could they be anchors for planetary bodies orbiting in complete blackness, cut off from light but warmed by geothermal energy, magnetic interactions, or the faint radiation escaping from the core? It's not impossible. We already know that rogue planets exist, worlds not tied to any star, drifting alone in interstellar space. If planets can exist without a parent star, then why not around a hidden one? And if there are planets, could there be life? That's the big question, right? We tend to assume life needs light, and usually visible light, because that's how it works here. Photosynthesis, vitamin D, circadian rhythms, it all depends on light. But that's Earth life. Life elsewhere might evolve completely differently. In fact, on our own planet, we've discovered ecosystems that survive deep under the ocean where sunlight never reaches. They live off thermal vents, converting chemicals into energy through chemosynthesis. If life can thrive in total darkness here, why not elsewhere? Why not on a moon orbiting a photosphere-less star, warmed by internal heat and energized by exotic chemistry? This isn't just science fiction, it's a challenge to our assumptions. For decades, our searches for life, for stars, for galaxies, have been biased toward the visible, toward the electromagnetic spectrum. We use optical telescopes, radio arrays, infrared sensors, but all of those depend on light or energy escaping from the object we're observing. If there's a whole class of objects that doesn't emit in those bands, or does so extremely faintly, then our maps of the cosmos are incomplete by default. And this might explain a lot of weirdness. The uneven distribution of visible matter in galaxies. The strange behavior of some binary systems. The missing mass in galactic clusters. The odd gravitational lensing events that don't line up with any visible source. What if all of those are signs of photosphere-less stars doing their quiet, invisible work behind the scenes. Even more radical ideas suggest that photosphere-less stars could be involved in cosmic censorship. The idea that the universe hides its most extreme phenomena behind event horizons. These stars could represent the edge cases, the ones that skirt the line between conventional matter and singularities. Objects so finely balanced that they don't collapse into black holes, but also don't radiate like regular stars. They could be balancing acts of physics, holding together in forms we haven't even imagined yet, governed by forces and laws that are only hinted at in our current models. And let's not ignore one of the eeriest possibilities of all. What if these objects are not natural at all? Think about that. Civilizations, if they survive long enough, might reach a point where they can manipulate stars, build Dyson spheres, create black hole power plants, hide themselves from observation by encasing their stars or cloaking their systems. A truly advanced species might choose to go dark, to become undetectable. Photosphere-less stars could, in some cases, be the remnants or constructs of civilizations that found a way to hide in plain sight. What we mistake for unusual stellar behavior might actually be evidence of technological engineering on a scale we can barely comprehend. That's not a conclusion we can jump to lightly, but it's not completely off the table either. Some researchers have proposed looking for infrared waste heat as a sign of artificial megastructures. But if a civilization is advanced enough, it might even mask that. It might deliberately design a system that releases no detectable energy at all. The ultimate stealth mode. If even a fraction of photosphere-less stars are artificial, then we're not just talking about astrophysics anymore. We're talking about cosmic archaeology. And in a way, we're only now beginning to develop the tools to explore these questions. The James Webb Space Telescope, with its infrared sensitivity, might already be seeing hints of these objects. The Vera Rubin Observatory could soon uncover massive datasets revealing gravitational oddities that don't align with visible sources. Gravitational wave observatories like LIGO and Virgo might eventually detect ripples in spacetime caused by interactions involving photosphere-less stars, collisions, mergers, tidal disruptions. These are just the first steps. We've always thought of the universe as a place filled with stars, bright, burning suns casting light into the void. But that may just be one version of reality. A comfortable, visible version. The real cosmos might be far darker, far stranger, and far more mysterious than we ever imagined. Photosphere-less stars might not just be one anomaly among many. They might be the true dominant form of matter, the silent majority shaping the universe from the shadows. On those planets? That's where things really start to twist your brain. Life, as we know it, depends heavily on energy, primarily from stars. But if we shift the framework and stop assuming that all life needs light, we begin to see new possibilities. Think about Earth's deep oceans. Entire ecosystems exist down there, miles beneath the surface, where sunlight never reaches. Those creatures survive by feeding off chemical energy from hydrothermal vents. It's a form of life that's completely independent of the sun. Now apply that idea to a planet orbiting a photosphere-less star. There's no visible light, no warm glow in the sky, no familiar day-night cycle. But if that hidden star still produces energy, say, through nuclear fusion in its core, that energy could be transmitted to its surrounding planets through radiation we can't detect, or even by heating up the core of a nearby planet just enough to maintain subsurface oceans. Imagine a world shrouded in eternal darkness, with strange, bioluminescent lifeforms roaming its surface or swimming beneath an icy crust. Life could evolve in silence and shadow, never needing sunlight, never even knowing what light is. And here's another layer to consider. If these stars are really out there, and if some of them host planets, then they could be hiding entire civilizations. Civilizations that grew up in a universe where the sky is always black. Where navigation isn't based on constellations, but on gravitational fields. Where knowledge of the cosmos doesn't come from telescopes, but from something else entirely. If intelligent life arose in such a system, would they ever discover us? Could they even imagine a universe filled with glowing stars, when all they've ever known is darkness? This idea is both fascinating and a little chilling. because it suggests that not only could the universe be more populated than we think, it might also be more hidden. It raises the question, how much have we missed simply because we've been looking for light? We've been focusing our instruments on the brightest objects in the sky, assuming that what shines is what matters. But maybe the real story is happening in the shadows, in the invisible structures and cold remnants that lurk between the stars. Think of how many astronomical discoveries have come from accidental observations. Pulsars, for example, were once mistaken for alien signals. Cosmic microwave background radiation was discovered when two scientists were trying to fix what they thought was noise in their antenna. Again and again, what we've dismissed as irrelevant turned out to be the most important clue. So maybe, hidden in the noise of the universe, are the signatures of these photosphere-less stars. Maybe they're all around us, lurking in the gaps, bending the light of galaxies ever so slightly, and making their presence known not by shining, but by pulling. And here's something to really think about. If photosphere-less stars are possible, what does that mean for stellar evolution as we understand it? Every model we've ever built is based on stars having photospheres. From the birth of a protostar in a gas cloud, to the fiery death of a red giant collapsing into a white dwarf, neutron star, or black hole, light is our marker. But what if that's only half the story? What if some stars take a different path? What if some never shine the way we expect? Imagine the earliest moments of the universe. The first stars were massive, hot, and short-lived. They exploded quickly, seeding the cosmos with heavier elements. But what if some of them didn't explode? What if some collapsed into dense, hidden objects that never radiated light? What if they were the first of the photosphere-less stars, primordial ghosts that have been drifting through space ever since? If these stars exist, we need a new language to describe them. They're not just invisible. They're not just faint. There's something else entirely. Maybe dark stars is too vague. Maybe stealth stars fits better. Or maybe we need a whole new category in astrophysics. Something that forces us to rewrite the textbooks and redefine what a star even is. Because if we've learned anything from exploring the cosmos, it's that the universe doesn't care about our definitions. It doesn't care what makes sense to us. It just is. And sometimes, the most extraordinary discoveries are the ones that make us uncomfortable. The ones that don't fit, that challenge our assumptions, that whisper from the darkness. You've missed something. We're trying to eliminate static from a radio antenna. They had no idea they were picking up the leftover radiation from the Big Bang itself. That's the kind of thing that makes you stop and realize just how blind we really are when it comes to the universe. Our discoveries often come not from looking in the right direction, but from noticing that something doesn't make sense. And that might be exactly how we stumble upon photosphere-less stars. Not by seeing them, but by noticing the effects they have on their surroundings. A planet orbiting in a seemingly empty patch of space. A gravitational lensing event that doesn't line up with any known object. A subtle distortion in the cosmic microwave background. Or maybe even a rogue object with a consistent pattern of movement, suggesting it's being influenced by something we can't see. We've already seen examples of this. In certain galaxies, the stars rotate at speeds that don't match up with the visible mass. That's how we first started suspecting dark matter. And when we looked closer, we noticed gravitational effects that pointed toward massive objects hidden from view. Some of these anomalies are still unexplained. What if a few of them aren't just clumps of invisible matter, but entire hidden stars? And what makes these stars different might not just be their outer shell. It might be something deeper, something that fundamentally changes how energy escapes from their core. One possibility scientists are considering involves ultra-strong magnetic fields. If a star has a magnetic field orders of magnitude stronger than anything we've observed, it could trap particles and radiation near its surface, forming a sort of magnetic cage. That would prevent light from escaping in the usual way. Instead of glowing outward, the star might pulse or flicker in strange wavelengths, or release energy in chaotic bursts. That could explain certain mysterious cosmic signals we've picked up, like fast radio bursts. These are short, powerful blasts of radio waves that seem to come from far outside our galaxy. Some repeat, some don't. Some come from places where we see nothing at all. What if, buried inside those empty regions of space, there's a photosphere-less star releasing energy in unpredictable pulses? We wouldn't see the star itself, we'd just catch its ghost-like echoes. And it doesn't stop there. Some theories go even deeper, literally. What if the reason we can't see some stars is because they're made of something entirely alien? Not hydrogen and helium like most stars we know, but some form of exotic matter that doesn't interact with photons the same way. Quark matter. Strange matter. Boson stars. These are all theoretical, but mathematically possible. A boson star, for example, would be made entirely of force-carrying particles rather than matter as we know it. It wouldn't have a surface. It might not even shine. But it would still have gravity, and it would still warp space around it. And we might have already found one without even realizing it. There are cases where we've spotted stars with bizarre behaviors. Their light flickers in patterns we can't explain. Their masses seem inconsistent. Their gravitational fields act weird. Some of these have been chalked up to binary systems, black holes, or neutron stars. But a few just don't add up. They don't fit any model we've built. They sit there, almost daring us to admit we don't know what we're looking at. And this is the humbling part of space science. For every mystery we solve, 10 more open up. For every star we chart, 1,000 more remain unseen. The universe isn't just bigger than we think, it's stranger. And the concept of photosphere-less stars proves that in the most mind-bending way. Because if these stars are real, and if they're out there right now, glowing invisibly in the darkness, they change the rules. They rewrite what it means to be a star. They challenge our instruments, our theories, even our sense of what's real. And most of all, they remind us of one terrifying, exhilarating truth: we've barely scratched the surface. Fundamentally different than the stars we know. What if some stars are made of exotic matter, stuff that doesn't behave like the elements in our periodic table, stuff that barely interacts with normal matter at all? This isn't just a science fiction idea. Theoretical physics has long speculated about quark stars and even stranger possibilities like preon stars, objects so dense and compact that they might not produce light in any recognizable form. They wouldn't shine. They wouldn't burn like our sun. Instead, they'd just sit there, exerting gravitational influence, maybe giving off weak, undetectable signals and rare particles, and otherwise remaining invisible to every kind of telescope we've built so far. These could be the cosmic shadows we keep overlooking. And it's not just because we don't have the technology to see them, it's because we've never even thought to look that way. That's the real tragedy of our limitations. We can only search for what we already expect to find. Everything we've built, our telescopes, sensors, algorithms, is designed to detect the familiar. Light, heat, radiation, X-rays, gamma rays, all built on the assumption that what exists out there must behave like what exists here. But what if that assumption is wrong? What if whole categories of objects exist that don't emit any of the usual signals? What if they've been sitting there, right under our noses, within our own galaxy even, bending space, pulling on nearby stars, hosting planets, and we just never realized it? Photosphere-less stars challenge the very framework of astronomy. They ask us to let go of a core idea, that stars must shine. They ask us to consider that visibility might not be the best metric for existence. And that realization doesn't just impact our understanding of stellar evolution, it shakes our entire perception of the cosmos. Because if stars can exist without shining, then entire galaxies might as well. Imagine vast regions of dark matter not being completely dead and inert, but hiding living, moving, dynamic systems, entire networks of invisible stars, maybe even harboring life. The dark galaxy hypothesis is no longer just some fringe theory. It's slowly creeping into serious astrophysical conversation, especially with the discovery of massive, low-surface brightness galaxies that seem to defy expectations. Let's pause on that idea for a moment. Galaxies that are so diffuse and so faint, they barely show up in surveys. If a galaxy can contain billions of stars and still be almost invisible, then imagine what else could be hiding in the dark. Some researchers believe that up to 90% of the matter in the universe is dark. That's not just a footnote in a physics book. That's a screaming signal telling us that we've only scratched the surface of what's out there. If 90% of the universe is hidden, what makes us think we've found even 10% of the types of stars that can exist? Photosphere-less stars might just be the bridge between the known and the unknown. They could be the first clue that the cosmos isn't just brighter or darker than we thought, it's stranger. And they raise questions we're nowhere near ready to answer. What if these stars are older than any others we've observed? What if they predate the universe as we understand it? Could they be remnants of a previous cosmic cycle, leftover cores from a universe that collapsed and gave birth to this one? Could they be observers, natural or even artificial, designed to hide, to watch, or to survive cosmic resets? And then comes the unsettling thought, what if some of them are alive? It sounds insane at first. But think about it. If consciousness is an emergent property of complexity, and if stars are massive systems with wildly complex dynamics, then what's to say that some form of stellar-scale intelligence couldn't emerge, especially in stars that don't emit radiation in the usual ways? Maybe these stars learned to suppress their light to survive longer. Maybe they found that radiating energy drew too much attention, so they evolved to hide. In the realm of science fiction? Sure. But every great discovery begins with a question that sounds crazy. We've already entertained the idea that black holes could be computers. That the universe itself might be a simulation. That dark matter could be made of particles from a parallel dimension. The idea of a non-radiating, intelligent stellar object isn't any weirder than those. And if any of it is true, then our cosmic neighborhood just got a whole lot more interesting, and a whole lot more terrifying. Because here's what it all comes down to. We don't know what we don't know. For all our satellites and spectrometers and telescopes, for all our data and simulations and star maps, we're still flying blind through an ocean of shadows. There could be millions, billions, of photosphere-less stars scattered throughout our galaxy. Some might be dead. Some might be forming. Some might be hosting worlds filled with life. And some might be watching. That they practically disappear into the blackness of space. These aren't tiny, insignificant clusters either. Some of these ultra-diffuse galaxies are as big as the Milky Way, but they contain only a fraction of the stars. And even the stars they do contain barely give off any light. What if many of these stars, or even most of them, are actually photosphere-less? That could explain why these massive galaxies appear ghostly and empty. Maybe they aren't empty at all. Maybe we're just blind to what's actually there. It would mean that our maps of the universe are woefully incomplete. That we've underestimated the number of stars, underestimated the amount of matter, and misunderstood the architecture of the cosmos. And the implications of that are massive. If our models are wrong because we missed an entire category of star, then all the equations we use, on dark energy, cosmic expansion, and even the fate of the universe, could be built on shaky ground. That's not just a mistake. That's a paradigm shift waiting to happen. And it gets even wilder when we remember that photosphere-less stars may not just exist, they may be more common than the ones that shine. Because here's the thing, shining is inefficient. A star that gives off visible light is constantly bleeding energy. If you want a long-lasting, stable, and nearly undetectable source of gravity, perfect for anchoring solar systems or hiding mass, then a non-radiating star is ideal. It's like nature's stealth mode. What if the universe prefers these kinds of stars because they last longer, stay quieter, and hold themselves together better over time? And now let's think about black holes. Traditionally, black holes are seen as the endpoint of stellar evolution. But what if they're not the only alternative? What if there's a different path, where a star doesn't collapse into a singularity, but instead becomes something equally dense, equally massive, but without a photosphere and without an event horizon? A stable, ultra-dense object that's invisible for all practical purposes but doesn't collapse entirely. That would rewrite our whole understanding of how matter behaves under extreme pressure. And some physicists are already floating the idea that so-called black stars, or gravastars, might actually fill that role. Objects that imitate black holes from a distance but don't quite match up upon closer inspection. Now take that idea and multiply it across the entire universe. Thousands, millions, billions of invisible stars, all contributing to gravity, but none to light. Holding together galaxies, hiding inside nebulae, maybe even giving birth to planets in their own right. Think about what that would mean for exoplanet research. We've spent years trying to find Earth-like planets around visible stars, assuming that life must orbit something we can see. But what if entire planetary systems exist around photosphere-less stars? They wouldn't just be hard to detect, they'd be almost impossible, unless we completely retool the way we search. And now here's where things get really unsettling. What if civilizations exist around these stars? Civilizations that evolved under dim skies or even pitch-black space, orbiting stars that don't shine. They wouldn't be using visible light. They wouldn't be broadcasting in the ways we expect. Maybe they never developed telescopes like ours, because they never needed to. Maybe their technology is based on gravity or neutrinos or other particles we barely even understand. And maybe that's why we've never found anyone. We've been looking for radio waves in a universe where the majority of intelligent life may not even be using electromagnetic communication at all. Our silence in the cosmos might not be due to a lack of life, but due to our blindness to the kinds of stars life might actually evolve around. Gravastars, short for gravitational vacuum stars, are hypothetical objects that could mimic black holes in many ways: immense mass, strong gravitational pull, and inability for light to escape. But they do so without the infamous singularity at their core. They replace the singularity with a shell of exotic matter that resists collapse, holding the structure together. Some theorists suggest these objects could be mistaken for black holes simply because we don't yet have the observational tools to tell the difference. But here's the jaw-dropping twist. If photosphere-less stars exist, and if some of them evolve into gravastars or similar exotic remnants, then we might be surrounded by these invisible giants, and not even know it. The implications are staggering. What we call a black hole candidate could actually be an entirely different class of object, something our current understanding doesn't even recognize. This raises a fundamental question: how many of the cosmic structures we observe, nebulae, quasars, even entire galaxies, are being influenced by invisible, undetected stars? Our telescopes pick up only what emits light or interacts with light. But if there's a whole population of matter out there that does either, our map of the universe is not just incomplete, it's misleading. The gravitational pull of these invisible stars could be warping galaxies, influencing planetary systems, and distorting the fabric of space-time, all while remaining undetected. Think about that. Entire regions of space could be dominated by structures we can't see, influencing everything around them like ghosts pulling the strings. It's like trying to understand how a city works while being blindfolded. You hear noises, feel wind, maybe even get bumped into, but you can't make out what's really around you. That's us with the cosmos. Now let's go even further. What if this idea doesn't just apply to individual stars or galaxies, but to the entire cosmic web? The universe is structured like a massive spiderweb, with filaments of galaxies stretching across billions of light years, connected by gravity and dark matter. But what if those filaments are also home to clusters of photosphere-less stars? Think about how that would change everything. We assume these filaments are held together mostly by dark matter, this mysterious substance that we can't detect directly but know must be there based on gravitational effects. But what if part of what we call dark matter is just regular matter hiding in plain sight, matter that simply doesn't glow? In other words, what if the universe isn't filled with an exotic, undetectable substance but instead with a more familiar one that's just playing by different rules? That would mean dark matter might not be as dark as we thought. It could be dim. It could be hiding behind the very physics we take for granted. And it gets even deeper. Imagine civilizations trying to find intelligent life in the universe. They point their telescopes, looking for light, radio waves, any form of electromagnetic communication. But if advanced civilizations evolved around photosphere-less stars, they'd be practically invisible to us. Their planets would orbit stars that don't shine. Their energy systems might not rely on solar power but on gravitational or magnetic interactions. Their habitats might be cooler, darker, and more stable over long time periods. If life exists in those systems, we wouldn't even know where to start looking. It's possible the famous Fermi paradox, the question of why we haven't found extraterrestrial life, might not be a matter of rarity, but of blindness. We might be peering into the darkness, not realizing that the darkness itself is where life thrives. This leads us to another strange thought. How would a photosphere-less star form? The standard model of stellar formation involves gas and dust collapsing under gravity, heating up, igniting fusion, and glowing as a result. But if that glow never happens, if for some reason the fusion process is altered or the outer layers of the star are hidden or absorbed, then the light never escapes. One theory is that such a star could be wrapped in a thick cocoon of neutral gas that absorbs visible light but lets through gravitational influence. Another possibility is that some stars form in regions so filled with interstellar dust that their light is smothered before it ever leaves their system. And there's the possibility of exotic states of matter, like quark stars or hypothetical dark stars, that radiate in non-visible spectrums or not at all. Even more chilling, what if we have already observed a photosphere-less star and didn't realize it? Some of the anomalies detected by Gaia and other observatories, objects that seem to warp the space around them but don't emit light, might not be black holes or data errors. They might be something entirely new. Something real. Something quietly massive. And these objects wouldn't have event horizons or emit Hawking radiation like black holes do, which means they could persist for trillions of years, longer than the visible stars we currently see. That makes them potential time capsules of the early universe. If we could study just one of them closely, it might hold the key to understanding how matter first organized itself after the Big Bang. But that's the problem, we can't get close. These stars don't shine. They don't mark their location with flares or pulses or emissions. They're the silent watchers of the cosmos. The only way to detect them is through indirect means, gravitational lensing, motion anomalies in nearby objects, or rare chance events like a planet briefly disappearing behind an invisible mass. And even then, confirmation is nearly impossible. We're left in a strange position, knowing something is out there, feeling its presence, watching its effects, but being unable to prove it exists in a traditional sense. It's like cosmic paranoia, but rooted in science. And now, let's take a step back and look at the big picture. For decades, astronomers believed the night sky told the story of the universe. The brighter the star, the more information we could gather. But what if the true story isn't in the light at all? What if the real secrets of the cosmos are hidden in the shadows, in the objects that don't shine, the structures that don't blink, and the stars that have no photosphere? If that's the case, then our entire exploration strategy needs to change. We've been building telescopes to see the visible. But to find these objects, we need instruments that see the invisible, not just infrared, not just X-ray, but gravitational and even quantum-level detection. This isn't just a new chapter in astronomy, it's a new book. And perhaps the most unsettling idea of all is this: if stars can exist without a photosphere, what else can? Can planets? Can entire galaxies be made of invisible matter, organized and structured but hidden? What if there are galaxies orbiting ours right now, made of photosphere-less stars and dark planets, influencing our galaxy without us realizing? We think we've charted the local group. We think we know what's near us. But what if there are entire structures silently coexisting with our own, shaping our fate without revealing themselves? Matter is actually an ocean of invisible stars, stars without photospheres, without light, without a trace of radiation for us to detect? That would be one of the biggest twists in the story of the universe. It would mean our theories about dark matter might be blending two different kinds of unknowns into one: exotic particles we've never seen, and massive structures like photosphere-less stars that we simply can't detect with light. This would suggest we've been staring at gravity's footprints all along without realizing who, or what, was making them. The gravitational architecture of the cosmos might be filled with these undetectable stars, creating silent frameworks that galaxies cling to. They'd be hiding in plain sight, contributing to the mass we attribute to dark matter while living a completely different evolutionary path than any luminous star we've ever studied. And here's where things get even more surreal. If such stars are real, they might not just be rare outliers, they could be ancient. Maybe they formed in the early universe, back when the laws of physics were still cooling down into their current state. We know that conditions in the infant cosmos were wildly different. Temperatures were higher, particle interactions were more extreme, and exotic forms of matter were much more common. It's entirely possible that some of those early stars were forged in ways that didn't lead to the usual thermonuclear burning we associate with stars today. If that's true, then some of these dark stars could be older than light itself, relics from a time before traditional stars could form. They might be the missing bridge between the Big Bang and the first galaxies. That means they aren't just hiding now, they've always been hidden. Now, imagine a future where we actually develop a way to detect these stars, not through light, but through something else entirely. Maybe through gravitational wave echoes, or through some kind of space-time fingerprint they leave behind. Maybe there are subtle shifts in the cosmic microwave background that we've misinterpreted. Maybe they leave gravitational lensing effects that are just a little too sharp, a little too strange to come from ordinary mass. When we finally develop the tools to distinguish these shadows from the light, we might open an entirely new chapter in astronomy. A whole hidden layer of the universe might come flooding into view, like turning on the lights in a room you never knew existed. Not just more stars, but different stars, older stars, stranger stars. And let's not forget the possibility that these stars might behave in ways we don't expect at all. If they don't have a photosphere, maybe they don't have a stable surface either. They might have turbulent outer layers that change constantly, or magnetic fields that behave in chaotic, unpredictable ways. They could emit faint neutrino bursts during internal reactions that we haven't yet attributed to stellar activity. Some scientists have even proposed that such objects could help explain strange signals we've picked up from space, signals that don't match any known astronomical source. These aren't science fiction ideas. They're real mysteries that have left astronomers scratching their heads. Could it be that at least some of these anomalies are caused by the hidden behaviors of photosphere-less stars? And speaking of strange behaviors, let's go back to our concept of stellar life cycles. In the standard model, stars go through predictable stages: birth, main sequence, red giant, then either white dwarf, neutron star, or black hole. But if a star never had a photosphere to begin with, that cycle might look completely different. Without visible light to mark its presence, without outward radiation pressure to balance gravity, maybe these stars collapse and expand in cycles we've never documented. Maybe they go dormant for billions of years before flaring up again in strange, non-thermal events. Maybe they periodically shed mass into the void, silently reshaping the regions of space around them. And if so, maybe these events are the cause of unexplained shifts in galactic motion or unexpected ripples in deep space. So what does this all mean for us? If the universe is full of unseen stars, stars that don't shine, stars that defy our understanding of what a star even is, then everything we think we know about space is incomplete. It means that light is not the only language the universe speaks. It means that some of the greatest players in the cosmic story are silent ones, influencing the plot from behind the scenes. And most chilling of all, it means we might never have a full picture. These objects don't want to be seen. They don't cooperate with our instruments. They leave no obvious signal. And yet they are out there, shaping galaxies, bending gravity, hiding in the folds of space-time itself. Older, colder, and more mysterious than anything we've ever imagined. Think about what that would mean for our place in the universe. We often look at the stars as these glowing milestones in the void, light beacons in the dark, guiding our understanding of cosmic evolution. But what if they're only part of the picture? What if our night sky is lying to us, not because it's incomplete in color or clarity, but because it's showing us only the things that emit light, not the full reality of what's actually out there? If photosphere-less stars exist in massive numbers, we've only been studying the universe's surface reflection, not its structure. We've mapped the city lights, but never the buildings. That realization would shift the very foundation of astrophysics. It wouldn't just challenge how we see stars, it would force us to rebuild how we define a star in the first place. We define stars based on light, temperature, spectrum, luminosity. Everything we know about them depends on what they give off. But if there are stars that never emit light, what happens to those categories? Are they still stars? Or are they a completely new class of object that breaks the rulebook we've trusted for centuries? It's humbling to imagine that such giants could be hiding in plain sight, invisible to our most powerful telescopes. We wouldn't even know how many of them there are. And the implications of that go far beyond astronomy. It affects cosmology, particle physics, even the search for life. Because if our estimates about star populations are wrong, then our guesses about planetary systems are wrong too. There could be billions of planets orbiting these dark stars, sitting in perpetual twilight, never illuminated, never seen. Entire solar systems might exist in complete darkness, with alien worlds spinning in the shadows. And if you really want to bend your mind, think about this. What if life evolved on one of those planets? We always assume that light is necessary for biology, because it's necessary for Earth biology. But that's an assumption rooted in a sample size of 1. If a planet orbits a photosphere-less star, its energy might come from tidal forces or internal heat, just like Europa or Enceladus in our own solar system. Life might have emerged in deep oceans beneath icy shells, never knowing starlight, never seeing a sun. If intelligent beings evolved in that kind of environment, their concept of the universe would be wildly different. They might not even have a word for light. To them, the cosmos would be a place of motion and warmth and gravity, not brightness. If they pointed a telescope toward Earth and saw our glowing sun, they might find it terrifying or unnatural, like a cosmic fireball. What we take for granted as life's foundation might be a rare and strange feature to them. But here's something even more interesting. Photosphere-less stars might not just be a curiosity, they could be a phase. Some scientists think certain theoretical models of stellar evolution allow for stars to pass through a dark phase, where the photosphere collapses or gets absorbed into a denser state. In that case, stars might be born with light, then lose it, then maybe regain it again depending on external conditions. That would suggest that light isn't a fixed property of stars, it's temporary. That kind of variability would shake up our entire understanding of stellar life cycles. Stars could be hibernating, flickering, disappearing and reappearing over cosmic time. And we would have absolutely no way of knowing, because all of our data relies on what we can see in electromagnetic wavelengths. We might be missing an entire class of stellar metamorphosis that happens behind the veil of visible light. This takes us back to the core problem with modern astronomy. We're visual creatures in a universe that doesn't always care to shine. Every discovery we make is biased by that fact. We found exoplanets by watching stars dim as planets passed in front of them. We map galaxies by the light of their stars. We hunt black holes by watching them distort the light around them. But what happens when there is no light? Our tools fail. Our models break. Our theories crumble. That's where the real frontier begins. That's where space becomes more than a place. It becomes a mystery machine, pulling back the curtain just enough to remind us that we don't know what we don't know. And it's in that unknown that things like photosphere-less stars hide. Not because they're rare, but because we're blind to them. Think about the silence of these stars. No radiation, no flare-ups, no visible explosions. Just gravity and mass, quietly shaping the orbits of things nearby, dragging galaxies into alignment, stabilizing the arms of spirals, anchoring dark nebulae. These silent giants could be the most influential objects in the universe precisely because they're undetectable. It's the perfect irony. The things we can't see might be the things that matter most. And if that doesn't keep you awake at night wondering what else we've missed, I don't know what will. And they develop technology in complete darkness. Imagine how differently they would perceive the universe. Their entire sensory experience would be shaped by sound, vibration, or maybe even electromagnetic fields, not by sight. Their mathematics, their communication, even their conception of space and time would be built on a foundation utterly alien to ours. To them, light might be a myth, something theoretical, not experiential. Their scientists might spend generations theorizing that some objects in the universe radiate energy in strange, invisible forms that only certain materials can detect. And if somehow one of their probes picked up faint signals from a luminous star, they might call it a ghost sun, or a radiant anomaly, just like we call their stars. Photosphere-less. To them, our bright, glowing solar system would be the exception, not the rule. We'd be the mystery. We'd be the ones living in the weird, blinding part of the universe. Now imagine two civilizations, one based in light, the other born in darkness, meeting for the first time. The clash in understanding would be beyond words. What if their eyes never evolved? What if their bodies adapted to absolute darkness in ways we can't even simulate? Would we even recognize each other as life? Or would our encounters be like watching static on a broken screen, failing to decode the signal beneath it? This isn't just science fiction. If photosphere-less stars are real and common, then the universe might already be teeming with life that's been invisible to us, not because we weren't looking, but because we didn't know where or how to look. Our instruments are built on the assumption that light reveals. But in these cases, light hides. It blinds us to what lurks just beyond the electromagnetic veil. And that brings up the deeper, more haunting question: how much of the universe are we actually blind to? The observable universe is defined not by what exists, but by what emits light or bends it. That's why dark matter remains one of the biggest mysteries of all. We know it's there, not because we see it, but because it pulls on everything else. Gravity doesn't lie. But what if some portion of that dark matter is just matter we've never been able to see, because it doesn't shine? What if it's made up of massive, cold stars that never ignited, failed giants, or maybe even entirely new stellar categories that operate outside known fusion mechanics? And if that's the case, then the universe isn't just mysterious, it's deceptive. It's full of massive entities that don't want to be seen, stars without light, planets without reflection, life without photos. This flips our entire philosophical framework. It turns exploration into a game not of discovery, but of humility. We'd have to admit that we've only been exploring the tip of the iceberg, the lit corners of a far larger, invisible universe. And with that humility comes a new kind of science, not one based solely on observation, but on inference. On subtle gravitational tugs. On the whispers between galaxies. On the unseen dance of matter without light. Astronomy would transform from stargazing to shadow hunting. We'd build telescopes not to see, but to detect distortion. We'd study anomalies in stellar movement, searching not for what's there, but for what isn't. And that shift would redefine how we fund space missions, how we build instruments, even how we teach physics in schools. The journey wouldn't be easy. We're talking about trying to map things that, by definition, don't show themselves. It's like listening for footsteps in a vacuum, or tracking shadows in a pitch-black room. But that's where the excitement lies. Because every now and then, science thrives when it embraces the unknown, when it stops trying to prove what it already suspects, and instead asks, what if we're completely wrong? That's the frontier we're standing on right now. We don't need to travel millions of light years to reach it. We just need to look at what's been hiding between the stars all along. What if dark matter isn't some exotic, invisible substance but simply an enormous population of photosphere-less stars, planets, and rogue systems that failed to form in a way that makes them visible to us? That possibility changes everything. It would mean we've been overestimating the rarity of star systems and underestimating the complexity of galactic architecture. Right now, we think stars light up the sky because they dominate it. But that's only because we're looking through the lens of light. It would be like living in a city at night and thinking the only buildings that exist are the ones with their lights on. The rest are there, standing tall in the dark, but invisible to the eye unless you feel for their walls or stumble into them. Photosphere-less stars might be the cosmic equivalent of those dark skyscrapers, completely real, vast, and quietly shaping the cosmos without us ever noticing. Think about that for a second, a whole network of dark structures woven into the universe, gravitationally pulling on everything else, but never lighting up. The stars we know, the bright ones, might just be the loud ones in a crowd. And maybe, just maybe, most of the crowd is silent. That would mean everything we know about the formation of galaxies, the behavior of matter on a cosmic scale, and even the timeline of the universe's evolution needs to be rewritten. We've spent decades modeling the universe based on light, mapping clusters, estimating mass, calculating distances. But if an entire class of stars exists outside that framework, then we've only been solving part of the puzzle. It's like trying to understand an iceberg by only measuring what sticks out of the water. The bulk, huge, massive, defining, could be hidden in the dark below. And this changes how we think about the Big Bang, too. After the initial expansion, the universe went dark for hundreds of millions of years. It was called the Cosmic Dark Ages. But maybe some of those early stars never actually shone. Maybe they collapsed inward before fusion could begin. Maybe they formed with exotic properties, strange densities or compositions that caused their outer layers to trap their own light. Or maybe they were born in environments where matter behaved differently, altered by extreme gravitational or quantum conditions. These wouldn't be just photosphere-less stars, they'd be a different kind of object entirely. And we wouldn't even know how many of them there are unless we start measuring the universe not with telescopes, but with the subtle pull of gravity, the whisper of gravitational waves, or the echo of ancient cosmic radiation. And that makes you wonder, how many of the unexplained gravitational lensing events we've seen, where light curves in ways we can't explain, might actually be caused by these invisible stars. Astronomers have already seen strange lensing effects that don't line up with the presence of any known object. The default explanation is often dark matter. But what if, in some of those cases, the lens is a star we just can't see because it has no photosphere? That would mean these stars are not just real, but active participants in the cosmic dance, bending space, distorting time, guiding light, even if they never emit any. It's like discovering that the people behind the curtain have been choreographing the entire play while we've only been watching the stage. And here's where things start to get really strange. If photosphere-less stars exist in great numbers, they wouldn't just hide, they'd evolve. They'd collapse, they'd spin, they'd even die. But how would we know when a star dies if it never really lived by our definition? Would there be a photosphere-less supernova? Could a dark star explode? What kind of shockwave would that send through the cosmos? A silent burst of gravity, a ripple in space-time, but no flash of light. We might already be picking up such signals, not recognizing them for what they are. And the implications don't stop there. What if these dark stars form dark planets? Whole planetary systems orbiting invisible stars? Think of it, rocky worlds with no sunrise, no sunset, just eternal night. Could life survive there? Could intelligence evolve? And maybe, just maybe, it already has. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.